Uh, so, so we are starting within 5 minutes.
Yeah. No problem. Thank you very much.
Good afternoon, sir.
Afternoon.
Yeah, sir, we can start now. Participants will
Okay.
join accordingly.
Okay, everything. I think my voice is okay, I think. Very
Yeah,
clear.
yes, I'll just give you a brief intro and then you can start.
Okay. Please
Yeah,
proceed.
yeah. Good afternoon, everyone. Hearty virtual welcome back to day 6, a final day of AICT Training and Learning Academy sponsored FDP on digital construction and green design, pathways to net zero. We, the Innovation Cell, NICMAR Delhi-NCR, commend every faculty member, scholar, and professional for reaching this milestone. Today, we consolidate the knowledge gained over the last 5 days into the ultimate objective building resilience. This FDP has consistently aimed to empower you with the cutting edge knowledge required to drive the sustainable transformation towards net zero. We have covered the entire life cycle from management day 1 and materials day 2 to longevity and digitalization through day 3 and 5. Today, we look at external threats and global standards to ensure a sustainable structures are also resilient structures. Today, day 6, we focus on global resilience and future application. Our first session is a critical look at how digital modeling tackles natural disasters. We expect today's session to be just as enlightening, insightful, and critically resilient. We kick off our technical session for the final day with session 11, running from 2 p.m. to 3:30 p.m. The session topic is Geospatial Wind Risk Modeling for Digital and Green Resilient Construction in Malaysia. This topic is critical, linking geospatial technology, climate resilience, and structural safety, an essential component of sustainable development. It is an exceptional privilege to welcome a leading international expert in wind engineering and structural resilience, Dr. Noram Irwan bin Ramli. Dr. Ramli currently serves as the Dean of the Faculty of Civil Engineering Technology, FTKA, at Universiti Malaysia, Pahang Al-Sultan Abdullah, UMPSA. His expertise is specialized, impactful, and globally recognized. His training in civil engineering, specialized in wind-related disaster risk reduction and geospatial modeling for infrastructure resilience. Also, he serves on the National Technical Committee responsible for revising the Malaysian Wind Load Code, contributing directly to Malaysia National Elects to MSEN 1991-14. He also chairs the National Conference on Wind Engineering. At the international level, Dr. Noram is active in the Asia-Pacific Economic Cooperation Wind Engineering Network, serving as Malaysia's official representative and co-chairman of the 8th APC Wind Workshop. Dr. Noram's session will provide essential insights into how digital geospatial tools are used in engineering structures that can withstand extreme weather, ensuring that our structures are also disaster-proof. After his presentation, the platform will be open for questions. So, I invite Dr. Noram Ramli to share his expertise. Sir, the platform is all yours.
Thank you very much, Ms. Chairman. Okay. Thank you very much. I'm very glad to be give some lectures today. During my lecture, maybe I will switch off my video, so maybe the line was more stable. Okay. Okay. Can you see my slide now?
Yes, sir, it's visible. Can you please put it on presentation mode, sir?
Okay. Okay, this is okay. Now you can view a presentation model.
Yes, sir, it's totally visible.
Okay, thank you very much.
Yes.
Thank you very much. Okay, before we start, I just introduce my topic today. I will say good afternoon to our friend and colleague in India. Well, good afternoon from the future, because I'm now is 2.5 hours in front of you. That means I'm from the future now. Okay, namaste again. Now in Malaysia is about 5 o'clock, 5 p.m. and this is Saturday. My topic today is Geospatial Wind Risk Modeling for Digital and Green Resilient Construction in Malaysia. And currently, as been introduced by our chairperson today, I was Dean in the Faculty of Civil Engineering Technology, Universiti Malaysia, Pahang Al-Sultan Abdullah. Okay, let's move today. Where am I actually? I'm very small country. We are very small country compared to India, where I think very large. We're very small compared to the size of India and the population of India. I'm in Malaysia now, and I'm just about in Kuala Lumpur. It's about 1.5 hours from Kuala Lumpur. My university is located here, but now I'm in my home, and I'm pretty sorry if some noise happened during my lectures. Okay, Universiti Malaysia Pahang Al-Sultan. Just let me introduce a little bit about my university, because my university is named is after the place Universiti Malaysia Pahang and the name of the king of the Pahang, Sultan Abdullah. That's why this name is Universiti Malaysia Pahang Sultan Abdullah. And we are just a public university in Malaysia. We are a technical university. We are also producing advanced TVETs. We are very young university, about 23 years, but we are not top 100 and top 150 university below 15 years. And currently, we're the best Malaysian university in the Malaysian Technical University Networks. I just a little bit introduction. We have a very good graduate ability of 99% for local employment rates, and we're going to do an international ranking and rating also now. Even we are young, but we still try to place ourselves to be in the ranks in the world ranks, other QS, THE, and also US News. Okay. But in Malaysia, we are ranked #1 in Malaysian Technical University Network. Compared to other Malaysian technical, we are #1 now. Okay, we have also some dual degree program with China, Kazakhstan, Germany, and the latest one with Korea. Maybe in future we'll be having with India, the dual degree program. And my faculty is offering various programs from the main of Bachelor of Civil Engineering Technology. We're also offering the Bachelor of Engineering Technology in Infrastructure and also in Energy and Environments. We have building, civil engineering and buildings. We have building Bachelor of Technology in Building Construction, diploma, and so also postgraduate course in Master in Civil Engineering and Doctor of Philosophy in Civil Engineering. We are welcome to visit my website. Okay, let's go towards our topic today. I'm just some little bit introduction. Digital construction in Malaysia. I noticed the India also they have roadmap, but let me share what happened in Malaysia. Now we are transforming the built environment through data simulation and integration. And the #1 agenda, the national push toward the digitalization, the CIDB actually as acronym is a Construction Industry Development Board. Construction 4.0. They have a strategic plan to promote the BIM, IoT, AI, and automation in the construction. We try to increase adoption of BIM for government projects, and we're doing some digital QA/QC through drones, laser scanning, and smart sensor. Right. Rather than that, we also have a geospatial technology in construction, where GIS increasingly used for land use analysis, terrain modeling, and hazard mapping. And this is also to support early site selection. We conduct especially risk assessment like my topic today and the infrastructure planning in the future. In geospatial also, we have some integration with BIM, improving the accuracy of the life cycle coordination of construction to promote the digital construction in Malaysia. And we also now transforming, so we have a digital twin potential for Malaysia, like real-time monitoring for bridge, building system, flood prone area, enable predictive maintenance, so we can have some simulation prior the construction and during the maintenance. And also this one also can be ready to support the wind risk modeling through the IoT-based structural response. And why it matters to have a digital construction? We want to reduce the target, to reduce the errors, reworks, and wastage. And this one is during the construction and enhance construction efficiency and collaboration, and form the backbone from data-driven, resilient, and low-carbon design. And in terms of green and resilient construction in Malaysia, our green construction principle is like maybe numbers of you here knows what is green construction. We try to reduce the embodied carbon through the material optimizations, improve the operational efficiencies, support circular economy using reuse, recycling, and low waste practice. And in Malaysia, Malaysia increasing exposure to thunderstorm winds and extreme rainfall and flooding. So in part of the climate change, in part of the natural disaster related, we also can have a digital plus greens. So we can have a wind safe building to avoid the reconstruction if the building is damaged due to the any natural disaster, or we can minimize the impact of the natural disaster, so we can produce more lower carbon footprint rather when we have to rebuild all buildings from the scratch, and ensure also the longer lifespan to reduce the lifetime emission. That's why in green in our study in our how to integrate the disaster risk reduction by applying some vulnerability. And in this case, I will share with you about how building vulnerability for residential safety and how Horizon Maps can guiding safer planner. And based on this risk-based retrofitting technique, for example, you have some heritage building you want to retrofit, you want to reinstate the buildings. So we have some information in digital. But in this today lecture, I will try to relate with the wind-related disaster. And why it support net zero? When we're talking about why we need to calculate the digital and the natural disasters also in our designs, is preventing the structure failures. And the structure failures or minimize the structure, we reduce the waste and the transport emission and materials. And digital modeling improve accuracy, and maybe we can protect some resource of old building, how to upgrade, how to mitigate, and also avoid over design for new buildings. Yeah, okay. And another thing is enhance long-term sustainability and community resilience. Okay, now we shall understanding the theme, digital construction and design on the path to the net zero. Why these things can be considered as sustainable. When we have a digital constructions, we also have a embedded green design in our design. This is towards the pathway to net zero. So we have some sustainable infrastructure in the future. Digital construction, like maybe I'm just repeat again some definition where we use tools actually to record the data, to record data to improve accuracy, planning, and coordination of the life cycle performance. And most of the tools I've been used is BIM, GIS, and digital twin. And green design is a design of building that reduce energy, minimize waste, use low carbon material, and support environmental protection. While pathway to net zero is combining both strategy, digital efficiency, and the green strategy. So to ensure the resilience of design to move towards the zero carbon and climate adaptive infrastructure. So in here, we have some, this is some of the basic definitions where digital plus green and plus resilient, we can make a sustainable built environment for the future. Just maybe some review of the construction phase. Maybe I think all of you in here is very expert in construction phase because you are from the center of most of you are from the center of construction material research. And we have 4 phases in the construction material, and if we notice, and some people say more than that, but I think it's a major in 4, which is planning, design, construction, operation, and maintenance. Why this geospatial wind risk modeling for digital and green risk construction in Malaysia? Well, first one, we need to site selection during our planning, and GIS and digital used to select safe and low risk, low impact development areas. We can choose where the maybe less prone area of the wind related risk, and in this example is risk wind, and we can have during the design, we can build a resilient building design, BIM and performance simulation applied to create efficient and resilient structure with the correct data, with almost the fact data. Okay, then another one, during construction, the digital monitoring and green practice used to produce waste, errors, and embedded carbon. And during the operation, we also can monitor if the changes in the surrounding or whatever. I will give an example after this. They will affect our building. That's why the importance of this combination of digitals, of the digital and the GIS in future. But what happens if we doing some inefficient building life cycle management? Like say we have poor planning, we are choosing the place where the higher risk of wind. Yeah, maybe we have to build some building in higher risk area, but we need to increase the designs. oh, maybe we're not suitable to be a very important building like hospital to be in the area that very risk. So it in the poor planning, it will lead to the construction errors. It will lead to increase the waste and also and towards the carbon emission numbers. And during the operation, maybe we neglected some impact that the changes when we're doing some changes to the buildings and to the surrounding buildings, and another one is inadequate design. So if we are not considering the risk during the construction, and for this topic, for the wind risk, we may have inadequate design for the buildings, and maybe the building will not sustainable for longer life. Okay. I do some integration of wind work. This is my tables. This is what is planning, why we choose in the place planning, what is been involved, what is the integration of the winners assessment. During the planning, yes, I mean discussed earlier at my last two slides, which is site analysis, zoning, environmental assessment. In wind risk, we're doing some geospatial wind map, surface roughness analysis, identify low exposure area, and safe development zones. In design, we're doing structure form, and the main focus is structure form, material efficiency. But in the integration of risk, we try to identify the building vulnerability index, help to optimize the structure performance to ensure the resilient to wind pressure. And during construction, the methods for main focus of construction is method, material, and workmanship. And here is strengthening the strategy guided by BVI, reduce some resource waste, and enhance the long-term durability. And during the operation, this is monitoring and performance evaluation of the buildings, and maybe you want to retrofit the buildings. Digital twin and GIS monitoring, detect vulnerability early, and support adaptive maintenance, promoting life cycle. For example, if you want to have a building adjacent to the older building, what will be impact to the older building? The new building maybe have increased some potential of wind speeds in this case, or maybe can also have some shielding to the building. Both can vice versa, was either negative or positive impact to the buildings. Okay, that's why it's sometimes we overlook a wind damage. We don't consider during the construction phase. We don't relate with the construction phase. We are working alone. We not integrated it, and it's like an iceberg. Iceberg, we can see only the small iceberg in the top of the sea water, but below the down, you can see numbers of what will be happens if we overlook winds, if we is not okay, wind is not visible, and sudden storm happens, and maybe the area is storm prone area, and the structural weakness, okay, non-uniform wind load, sustainability problem, green resilience design. So they have more wind-related disaster factors that may be missed and overlooks during the proposal or planning, and it will cause of damage. Even in reality, we just see a wind-related disaster is due to the high piece gas of the wind speed, but actually numbers of the other factors may reduce the impact of wind-related disaster. I just to plot, this is maybe some of you in the wind engineering may be familiar. We have wind-related risk chain. They've been produced by Professor Edgy Davenport wind load chain. They have 5 wind load chains, but I'm trying to map to wind-related risk and to the digital green relevance into the constructions. You see in the Davenport, they have load chain, they have 5 parameter: wind, terrain, aerodynamic, response structure, and criteria. But a wind is actually, and wind related is a natural wind climate. What this means, we always have the design based on basic wind speed at macro and meso scale. Refer to the code. I noticed Indian also have the wind load code, but we don't have more data about climate data downscaling. Thunderstorm. In Malaysia, there's a thunderstorm and the long-term weekend. And the second one is the impact of terrain, because the exposure factor based on the roughness, land use, hill coastal effect will much affected our winds character. Different exposure will have a different factor to the winds. They can slow the winds and they can also increase the wind speed. And digital and green relevance, we can use some GIS. We also have digitalization model, land use change, urban adventure, and we do some green buffer. So we know where we want to identify in digital ways under the records. Okay. Another one is aerodynamics. This is building interaction, how the building is absorbed the loads from the winds, and the aerodynamic coefficient based on the building shape, the orientation. And during the planning, if we know the wind direction, which most is wind direction, we can have some adjustment of the directions, openings, orientation, so we can reduce some the structure. They will reduce some loads, so we can optimize some during the design stage. And in digital, we can use CFD, BIM, and we also have some ventilations and green facade. And when we talk about after we accept the pressure from the buildings based on the shape, the response structure, the main structure, the beam, the column, the frame, that's what, if we can have identified earlier, we may reduce the some load and some potential of high risk. So we can minimize the impact of wind-related risk during the design stage. And in this thing is we can have a digital twin of structural modeling at early during the design and construction stage. So we can monitor, we can have simulation rather than trial and error during the construction. And the last one is criteria. The criteria is related to damage and environmental impacts. The criteria, okay. The criteria. Okay, the criteria, sorry, I'm using the symbol. Okay, there's a, what does this mean? Is a limit state, safety level, performance target, a wobble. This is also can represent in the codes, structural codes, most of the structural codes. And in digital, we can have a better durability, less rework, and lower carbon footprint by optimize the design. Okay, how we want to identify the wind-related risk in the specific location. This is actually, we want to find at the local wind speed estimation. Local wind speed may differ from one area to another one area. Most of the study using regional data. I will show the example of this. And using the extreme value analysis, this is the most common. We estimate the design wind speeds. But in detail, we have to we also have to consider the terrain roughness and adjustment, so we can get the better local wind speed. And based on the height and topography correction, adjust for building height and topography, we get the final local wind side, local side wind speeds based on the all four parameters before. That's why this is like a bridge. You have to go through the process. But most of the study, most of the designer just refer to the original wind data. That's me, maybe will overlook, and sometimes we will under design. And in terms of building vulnerability index, in this study, we try to digital scoring system to quantify how likely building is to be damaged by the wind. And I will identify which building are more vulnerable during the operation and maintenance, and maybe we have to and we produce some BBI to identify the risk-based planning and prioritize retrofitting. If we know the vulnerability of buildings, we know the potential of hazard of the area, we can identify the risk of the building. So we can retrofit and restrengthening which building or which components based on the digital models. in building vulnerability index, we have a lot of parameters. This is our proposed parameters. Building structure system. What is it? Is it timber, masonry? Maybe is in America they call HAZUS. They have some other one method called HAZUS, and they have a roof type encourage, type of wall, building age, also the maintenance level. Other maintenance level are regularly, and also the most important is exposure in the surrounding of the environment. This is the vulnerability impact. Okay, let's say what is happened when manual versus vulnerable digital vulnerability assessment. Manual vulnerability, maybe we can have to use POM, we have to evaluate, we have inefficient, time consuming, and some inaccurate, because the perception, not the perception, because the evaluation from each person to each person will be different. So if we can digital everything, we hope that we can last and minimize the error in evaluate the vulnerability assessment. These become integrations, score indicator. We have geospatial layer after this, vulnerability maps and hazard map integration. So we have a digital vulnerability assessments. Of course, in Malaysia, wind-related damage has become increasingly and evident in northern region of Peninsula, where I'm now, as a particularly in few states, are increased. Although Malaysia is not within the typhoon pathway, but localized windstorm, monsoon gas, and convecting downdraft have caused frequent structures failure, especially to the roof, lightweight buildings, and public facility. Even we have a current national code, Malaysia 1553, provide only the broad wind zone and do not reflect local variation in terrain topography and land use. As a result, wind risk is often some underestimated in exposed area, and planner lack detailed spatial guidance, because when they interpret their exposed area, the way it interprets the structure system may be different because they don't have a digital reference. Okay, this is some example of damage of a rural house due to windstorm in Peninsula Malaysia. This is mostly a village house. Okay, this is schoolhouse. You see on the left, on the right side, they have a blue roof. This is roof tile of lifted, and you can see if I can share the slide later. You can see the truss is still contact, and this truss is still working, but the roof cladding is mostly failure. Okay. This is damage of some rural areas. This is happening in Kuantan near our university area, and it also some say this is mostly rural and non-engineered buildings, but this is engineered buildings also happen. Engineered buildings, engineered building happen. You can see the steel truss still working in here, but the roof claddings have been suctions by the windstorms. Okay, you can see here how the damage of roof claddings. Okay, this is a damage recorded in Peninsula Malaysia. We have both in Malaysia. We have one site in Peninsula, another one in Borneo. Okay, this is last 15 years damage we recorded. If you can see here, they are tabulated mostly surround the country, but it have some trend if we try to identify. So if we're doing some recorded we identified some damage related to windstorm in Peninsular Malaysia. This is the case. And you can see the most of the storm occurs at the evening of time. Okay, it's about 6 o'clock in the PM. Okay. And the trend of the related damage is always is higher at April and September. This is actually the intermonsoon season, where the monsoon change and it's increased during the intermonsoon. In terms of day, they also happen. We don't have any specific day. Every day in a month, there are possibility to occur. Okay, because we are very impact by thunderstorm, which may occur anytime within 15 and 30 minutes. Okay, we try to make a storm statistic based on area, and we can see the in the northern area is a higher number of damage. For the last 10 years, 2010 to 2020, for the last within the 10 years, in 2010 to 2020, it's the most highest numbers. So we thinking of doing some study. We can see here, even the population in this state is very low. But the case of this is our record from 2009 to 2016. This record is showed higher numbers of damage, higher numbers of wind-related damage, but very low population compared to some state. This is Selangor, almost near to the Kuala Lumpur's higher population, but very less damage. This is due some, I think, aspect. Why? Because of design considerations, and in the city area, they are good enforcement, and also their awareness is higher compared to the remote area. So, based on the wind speed, this is previously just a zoning wind speed. We have a wind speed on the shoreline and the middle, same as like Japan. In Japan, they're also giving a wind speed in a regional area. Australia also same. I just go through some other country. This is in all over the world. They just given some wind speed. Just also in India. This one just I found some reference in website. They're also giving a wind speed based on area, and which area mostly dominate have highly related wind related damage. We don't know because based on this data we can't see where should the high risk. Maybe we can judge based on the wind speed. The blue color is this one is a higher wind speed. Higher wind speed will be a higher potential. That's only assumption that we can do. So, how we process our wind hazard map, actually, we're doing some data processing, we're doing some terrain classification, we done topography assessment, and we have wind field development and hazard map generation. I just keep that thing as because wind risk actually risk is equal to hazard. The risk is function of hazard and vulnerability. And wind risk is actually a combination of the hazard of related wind and vulnerability of to the susceptibility to the wind damage. So this will we try to find the high risk zone, and it's a journey path where we need to have initial data, we need to have a wind speed, we have the building properties, we have to identify the hazard layer, wind exposure maps, vulnerability layer, building weakness assessment, overlay in a GIS, and wind risk map can be displayed. I will show you an example. Okay. This is our step from hazard layer creation to final output, the generate output and the recommendation. How we produce the and generate the risk map. Okay. Before we go, maybe you can have some just a few tests, not tests, just refreshment now. If you see this switch here, how many of you can see a color. I don't think you can see any color in it. This is a beautiful flowers, gardens. Garden. Yeah, thank you. Maybe you may ask in the chat box. Also, you may interrupt me if you have any question. But it's in black and white. We can identify flowers. We can identify butterfly. But maybe difficult because maybe difficult because we only have a monotone color, only one color, black and white. But if it is colorful, that's more better because we can identify where is bugs, ladybugs, where is a sunflower, where is a rose, where is a butterfly. Color is more when this is mean we can identify, we can categorize. But however, when we asking how many flowers in rates, we are getting difficulty in more difficulty in identifying because too much color, and this is life actually. This is our brain. We look, and this is our assumption during our construction. There are few colors we can't identify because our brain is very good actually, but limited. So if we just color a few colors, a rose or a few type of flowers, then we can identify easily, or we can count easily. Okay, we have 1, 2, 3 flowers of pink flowers, because if we can categorize like this, but I think brain cannot do this. Only the assistant. Okay, this is my words. The human brain is powerful, but limited by emotion and distraction. Sometimes you're happy, sometimes you're sad, sometimes you have your health is not in good condition, which can affect the decision making. So we have to go to the digital in helping our human brains. Okay, we go back to the damage statistic that locate in our country. We just to focus in this area because this damage is really high. This damage is really high. Area. Okay, what happened? Okay, if we see this is a windstorm damage. Okay, we have some question. Okay, I'll explain it first. Okay, if we see some windstorm damage in this region, there are you can see it's almostly happen recurrently at more or less same area, but because everything is green, everything is dotted with green color, we can identify. But when we try to plot, we have the brain sheet 2010 2016 in the red colors, and we lay with the 2017 and 2022 records. We can see the green color actually overlaying with the past storm damage. It means that the storm, the damage is recurrent at the same place from this observation. I think this is when we try to clustering like a flower, like one example, like a flower, we notice that the damage actually, the windstorm, are repeatedly occurring, mostly at the same place. Okay. Okay. This is how the methodology we get some potential side wind speed, and we always just given the Malaysian basic wind speeds, maybe not in Malaysia, other countries also. This one not, and the latest one is updated, but this is only the tables. We can't find where is danger. Maybe we can assume, oh, the speed is higher in Ipoh, based on the wind speed. But normally, there are also other factors that cause the hazards, the potential of wind-related disaster. Okay, so we interpolate the basic wind speeds, And we see here now, by interpolations, is go the basic wind speed based on the 15 years. We try to categorize some, oh, sorry. Okay. This is actually, maybe you can read also forest, rubber, degraded, paddy field, and other crops. We try to categorize the covers, the land use cover, and we let the land use, we plot the land use, we categorize the land use into the coefficients. Let's touch what actually in the codes, and we categorize the topography class into the value of coefficients to the slope. Sorry. Okay. And then from here we have a potential coefficient of wind speed or specific sign, because numbers of criteria. This is based on the Davenport's wind load change, but number of criteria also can be introduced. But for this study, I'm just specific to this. Is a main character, and we produce the wind speed, and after that we times the basic wind speed with the potential of multiplier wind speed. Some area may reduce, some may increase. And from the result, you can see here. This is a frequency of the damage. Look at the percentage of the damage. Look at numbers. If based on only basic wind speed, the macro scale, based on table, based on the plotting of basic wind speed, the wind speed, the mean wind speed here is 28. But after we doing some micro scale and multi-criteria enhancements, we see that the potential of wind speed now become more higher. The potential of wind speed based on the damage frequency is more higher compared to the only. And we try, if we increase some basic wind speed based on a little bit narrow down into the state and districts, a little bit scales, it will increase the potential of high wind speed based on the damage frequency. And yes, from that we can see, as a result, many of reported damage were located in zone where the site wind speed was greater than the mean potential wind level. This observation suggests that the damage not occur randomly, but is more likely to happen in areas where intensity is locally amplified. Although not all high wind areas experience equal level of impact, the concentration of damage in this zone highlight the importance of accounting for strike speed wind variation when assessing the structural risk. I think we have some question. I have one question there. What will be the question? What are the key challenges in modeling risk in tropical climate like Malaysia, and how they address? What is the okay. What is the most challenge in modeling risk in a tropical such in Malaysia? I think the most critical, we need to have a good data of relevant damage. And during my start of work in 2010, I always say they have no officials, even unofficial record the damage. I've been in Tokyo Polytechnic University, become research fellow, and after that, I'm aware that creating a database is very important. The wind-related damage database is a main #1 steps. If you don't have this, we cannot proceed with other things. So from 2010 until 2016, we are working with a team from a few universities in Malaysia, try to collecting the data. This is the most challenge. And from the data, we can see the trend, where the time of storm happen, where the location is happen. Because it's happened all over the nations, but some area are frequently occurs compared to some other area. So I think the most challenge is collecting data, even in tropical, okay, in impact, in aspect of climates, I think. And that one is in terms of data, in impact of climates. The problem is the problem in climates in Malaysia, because we almost facing the thunderstorm event, which is in the micro downburst. It's not have a very big like typhoons. So they are also not easy to measure measure the real winds speeds at the damaged locations. The wind station is another issue. We have wind station, but wind station always not all the time wind station the damage is happen at the relative wind station. So I think if we have data now, we have to introduce numbers of wind station at the damaged area. That's a challenge, I think. I think maybe we shall improve how to first collect data, how to collect the climate data, especially at the high risk prone region related damage of winds. I think I answered that. Okay. Actually, this is I'm referring back to the Davenport wind load change and how we actually produce the hazard map based on wind and terrain. This is actually two main factors, but we have enhanced the factors with number of other criteria. So, and the balance criteria, the balance chain is aerodynamic response structure, and also the criteria is actually goes to building, but it's a vulnerability, which is in here is a building vulnerability. So, if you have a wind pressure and the force of buildings, this is a decision like a decision trees. Manually, I think if you have always make a designs, we say, oh, what the buildings are, either the rows, but is you need to identify the height of the buildings. Is it a low 10 meters or high more than 10 meters? Is it isolated or non-isolated? This is become the assumption may lead to error. Okay. Okay. Sorry. Okay. The assumption may lead to the error. There are a lot of type of roof. They have a potential, a different vulnerability. And if they're isolated and so non-isolated area, they also give another vulnerability. So also at the medium and high-rise building, if non-isolated, what will happen with non-isolated buildings, isolated building, or a tall building in isolated area compared to tall building in the city area, they will be different. Either they have been rectangular, square, or combination. There will be number of three here, a number of three coming after this, okay? And also the impact of wind force, such as tornadoes, thunderstorm, typhoons. They will have a various configuration impact to the buildings. So this is what we try in considering in building vulnerability in manually, and we can generate more decision like a decision tree. But now a lot of people are conducting study in wind channel in CFD using a number of software, a good modern technique software, and this is from TBU database in 2025. You may go to Tokyo Polytechnic University aerodynamic database. They are freely to use. Okay, you can see now this is a normal building, normal house, very normal house. They have a A-shaped roof and different orientation of the wind speed. This will first come from here, second wind direction, third wind direction, and fourth wind direction. Different wind direction giving different pressure. So if we notice the wind rules, we notice the major direction of winds, we may orientate the buildings, or maybe we can optimize some design. But manually, I think it will become more difficult compared to if we can have a digital digital model so we can orientate easily. We also do, yes, number of research. This is also research by Prof. Tamura and all. If you're searching Prof. Tamura is a well-known professor in wind engineering. He's doing a lot of stuff in a higher building. We can show the difference of shape building of tall building, different configuration will have a different wind load impact. So this is a vulnerability. And also actually his study find also the impact of the pedestrian level. That's why I'm saying the adjacent building, when the new building built to the older adjacent to the old building may impact the older building, or may the older building may also impact the new building. We have to conducting some vulnerability testing in the winter. So this one can be digital. When we can have a digital, we can have a combinations of hazard and vulnerability. So we may identify the potential risk of the building, or maybe we want to modify some of the surrounded. Maybe want to, yes, in some country, they remove some old building. Maybe there will be impact because the wind impact will be different after they remove some of the buildings and the constant new building with maybe more modern shapes, very not a square shape, very nice shape, but it will affect the current building. So I think this is vulnerability that numbers of people are studied, but not been digital. So I try actually, whatever things is Devonport change, which is I think the fathers of modern winds. And if we can identify digital all these things one by one, and I think we can have a good criteria. And for example, we have AI-based wind down scaling, weather station with IoT, radar satellite wind observations. This is dream. This is a perfect one. But currently, we towards that, but we don't have reached this look. Okay, we can digital some land use, urban morphology analysis, because we need to update our city, because some city is very fast, and especially new city maybe can have a optimization of low carbon footprint, and also the aerodynamic impact, response structure, and last one is the criteria, how LLM, large language model, can assist our performance. Like I'm saying, when we counted the rows with numbers of colors, we can find easily. But if we can have some filter on the eyes, so we can collect only a few things and we can count easily. So it's a multi-criteria evaluation using digital models, and if we can propose such a thing, combination of wind-related risk, hazards, vulnerability, and we can find what is the potential related risk for the specific building. Towards the net zero in buildings, I just repeat it again. This is some, I think it's mostly same as previous, but been representing in a way in a mind map chat again. And this is towards the digital twins. In digital twin, we have to collect all this data, all this parameter, like what I say, the challenge. We want to move to digital twins, but we have to have a basic data. We have done the reference, we have done baselines. So we have to update and collect all this data first before we can go to digital twins. And green design is actually mostly related to what we have, the data we have, the best data we have, the good data, the more better decision we can make to ensure the green design. Yes, the digital constructions is across all the phase. How we want to, from the high exposure area to reduce the extended the building of lifespan. They have 4 phases, and during the 4 phase, we need to integrate all the related damage. For this case, I will say wind-related risk reduction, but others case may be natural disaster or other things. we need to be in the planning phase. We have to improve in the designs, in the construction phase, and the operation phase, and guide the maintenance and retrofit to ensure the extended the building lifespan. I go for my summary. Digital tool from wind engineering. Yes, we need to turning the physical wind behavior into digital knowledge. We have need to geospatial modeling, land use mapping, and whatever relevant data have to be mapped in the digitals. And local wind matters more than regional wind speeds. And like I'm saying, we have to identify the local specific site wind speeds at each location. We can have we cannot refer to the regional one because maybe we are misled or maybe we are underestimated. So we can improve the accuracy and the safety. And vulnerability is important as hazards. Building form, we need to digital the buildings so we can identify the potential vulnerability of the buildings and also to support risk-based strengthening and retrofitting plan for the future. And wind risk mapping protect committee, they identify the critical zones, guide safe land use planning, prioritize mitigation, and directly reduce disaster loss. And wind resilient design is green designs, because when we have a less damage, we have less construction, we can reduce waste, reduce embodied carbons, longer building lifespan, and support the net zero pathway. And why digital twin plus GIS? Okay, digital twin is real performance of the buildings, and GIS environmental and spatial wind hazard context. And combined in, we have the geospatial wind risk modeling. And just recap, how do they work? I think I've been explaining earlier in my presentations. This is digital twins, a combination, the integration can make a risk assessment, okay? And I think this is repeated, but we maybe we can go because my presentation always give me the positive, but I also find some pros and cons during this study, because the process will prevent wind damage, improve reusability, well, what I've been discussed. But the contrast is the potentially high initial cost, the complex implementation, and sometimes it's a data security concern, because when we're sharing everything, some area maybe not be can share easily. Some data cannot be shared. This is some things that we have to think into the future. This is some contrast, some pros and cons that I just want to highlight. And towards last but not least, why it support the green design and net zero to prevent wind damage. It reduce risk constructions, carbon, improve durability and lifespan, enable data-driven and low-carbon decision-making, support nature pathway to green resilient construction. I like this picture actually. Why I think second time I'm use this figure, because we are now everything need a step. You are like a caterpillar that will be fly as a butterflies, but if you not start the first step, it's a traditional constructions. But if you're not thinking to move step, it to become next become a lava. Maybe it's just one step. Collect the data, collect the relevant damage data, whatever. Maybe in this case is wind-related risk. This is a step, but one step make you be flying. You don't know when, but I'm sure this is the flow of the parts. One day will be achieved. All the restriction, all the buffer that we have facing of the challenge towards the net zero. I think India are also towards net zero plan. Also in Malaysia, we are also enforcement net zero plan. Okay, and let's say for me, I want to let's say please make a step, because first step is it's not easy, but after that you will move further and far. And this is a recent and future work actually. I've noticed when I'm invited by Professor Goyal and NICMAR for giving a lecture in India, in countries such as India, I noticed that they have a lot of brain drain in India, very good in computing, very good in IoT, very good in AI. I noticed that, and this is my future view. We want to go towards the end, large language model based on wind disaster risk reductions, where we can have some LLM for wind-related disaster. But I think they have no, until now, they have no LLM wind-related disaster. And if we can doing some digital integration, so they can answer for us, and to ensure we can get better answer, get a better, safer towards the future. Okay, this is my future, my recent and my future work. But I welcome all the from all of my friends in these lectures. If you want to collaborate with me, you is most welcome. And this is actually just share some of my working. We try to synergy with some normal maps, so people are public people also can be used. This one is actually nation map. We try to map where the potential risk areas, so they can easily understand, identify, and this actually lay on the gray color is actually transmission grid line been overlaid all over the Malaysias. So we notice where we need to retrofit, where our mitigation to restrain our transmission lines of electricity, the higher voltage one. Okay. So this is last and an example. I would say this is past. This is my picture present this year 2025. This picture taken in 2015, mostly 10 years difference. And maybe we can't predict. I also can't predict myself on that time. So maybe if we have some LLM, maybe we can, on that time, I can ask, what is potential on my face in future? But we don't know in the future. Hopefully somebody can help me answer this. Like what I'm probably my recent works and ongoing works. So the past, present, future, we don't know about the future, but let's work together. With that, thank you very much. I'm Noram Irwan Ramli from Malaysia, from Universiti Malaysia, Pahang, Al-Sultan Abdullah. And this is my email, my official email in the Noram at UMPSA.edu.my, and my personal email. I will share my slide with the secretariat in the PDF version, and I think you may get the slide from the secretariat of this lecture. With that, thank you very much.
Thank you so much, sir. We are having some questions in the chat box.
Okay, thanks.
Yeah, so the first question was, what are the key challenges in modeling wind risk in tropical climates like Malaysia's, and how are they addressed?
Yes, I think that's one I have addressed during my lectures. We go for the Rivan's question, I think, because okay, wait, I share my video. What are the key? Again, I think we move for the second question, because first question, I mean.
Okay, sure, yeah. The next question was from Vikhyat. When regional wind maps doesn't capture local terrain and height effects well, how can we be sure that our corrected local wind speed is accurate, especially for short, intense events like local windstorms that long-term climate data might miss?
How can we be sure that our corrected local wind speed is okay? Okay, the best is we can measure the side winds. That's why to increase the numbers of weather station is a must. And in Malaysia, is a challenge is numbers of the official wind speeds station or meteorological station, not wind speed, meteorological is still like. So if we can measure on site, that's one we can compare to our prediction actually, yeah, to verify. Yeah.
Okay, thank you, sir. And next question is from Irwan. Like, what are the key research gaps in wind resilient digital construction that young researchers should focus on?
What are the key research gap in wind resilient digital construction that young researchers should focus? Okay, I think you have to focus on the fundamental of understanding of wind itself. Wind is most of the design. We need to understand the physical behavior of the wind flow, wind speeds, wind character. If we understand the wind character, how they flow away, how they flow, what is disturbing it, what is make the increase, what will create the potential of storm, then this is the fundamental understanding in wind speed. So we might miss what the important data. And is it possible to create a performance score inside BIM that update live as the model change? I just read the second question. Okay. Is it possible to create wind performance score? Yes, I think you need to customize it. I don't think they have the standard of software available, but I think you need to customize it. Yeah, we can develop this. Yeah, potential to develop. Next.
Next was, sir, how do you integrate wind risk models with Beam, other digital construction platforms?
How do you integrate wind risk model with Beam and other digital construction? Can I have I just based on I understand what based on these questions. To integrate the wind risk model with BIMs. Okay, actually, BIMs are tools. Okay. Yes, it's a tools that we can use to make the modeling to the buildings. But however, the wind risk actually wind risk is after you combine of the BIM plus the hazard potential. The hazard actually the potential wind speed at a specific location or a specific point. So if you integrate that, you have a wind speeds and you have the models which is digital. My assumption is can be represented digital twins, so you can have identify the potential wind risk. But I don't see any BIM tools now. Maybe integrate directly. Maybe have, but I won't find it. Yeah.
Any more questions from audiences? Please ask. We still have 10 minutes to wrap the session up.
Okay, one I don't know. How can digital twin unify climate data and CFD aerodynamic? Okay, when we have a digital twins, we have the information of the buildings, the size of the column beams, the size of the claddings, the cladding area, the non-cladding, the openings. This is the 3D modelings that we need before we conduct some CFD. So if we have the details, we can go to generate potential of coefficients, wind coefficient based on the CFD. And also we can have create models and testing the wind tunnel in the traditional way. But so I think how can digital twin unify climate data? Unify climate data, I think directly maybe the location, the situation of the building. We need the information of the data of maybe historical data of the wind speed on that area, the potential or the recorded maximum wind speed data, or the related damage that been occurs surrounding that building. That's I think should be put in a digital twin information. So we can model it. Okay, next.
Yeah, Mr. Noram, Colonel Rajendra on the side.
Yeah,
so I was in fact listening to this one. It's a very good expression of the topic.
Thank you very much.
We just want to know exactly where do we stand as far as, in fact, the codification of the inclusion of geospatial and risk modeling in terms of some codes or some such initiatives like green building guidelines or something of that sort has been done in Malaysia, in your country?
Yes, we have some roadmap been established in the greens for the greens, but I don't think it's almost complete. Until now, we have a roadmap. We have some guidance, but not yet. I think it's not.
So as of now, these are guidelines only. I believe there is nothing much concrete in this, isn't it?
Yes, yeah.
So how effectively has it been implemented in your country, and how do you see its in fact scope?
We have some index here. We are also in our CIDB Construction Industry Board. We have some skill index. We introduced the index. If the contractor in the construction meet the score index, maybe after this we can share in another lecture or whatever. After scoring some score index, they can have a levy. They can have a waive of the levy constructions, and we categorize some buildings either in the green GBI according to Green Building Index and Green Building green operations. They have several factors. There are several initiative now, like in the last, maybe this year, no, not last, this year, we now try to put a new guideline how to use the recycle waste from the construction materials, so we can towards the greens constructions, because we now generate the guideline now how we can produce it, how much percentage, because not much reporting that we get during the constructions, how many they are using the recycles things.
Has it been integrated, the AIM thing, has it been integrated in the geospatial and risk modeling?
No, not yet.
Artificial intelligence?
Yeah, not yet. I think
not yet. So I think it will be really something worthwhile in case if it is integrated.
Yeah, it's good if we can integrate it. But I'm not good in I'm not the computer literate person. I'm trained as civil engineer. That's why my handicap. That's why
we all are actually, it's a forum of all civil engineers only. I think people actually who matter in terms of decision making. They are the ones actually who should take a call. But I think it's a really worthwhile issue which one can always really further explore into it. And once there's some sort of the guideline, they fructify in terms of some such concrete models or some such impact codes. I think it'll help, and it'll be a global sort of a phenomenon that it would be something like that. Thank you so much.
Yeah, it's a good suggestion, sir. It's a good suggestion.
Thank you, sir. Thank you.
Okay, thank you very much.
Thank you, Dr. Noram, for that exceptionally important session on geospatial wind risk modeling. Your expertise, drawing from your leadership at UMPSA and the National Technical Committees in Malaysia, has provided a crucial international perspective on integrating resilience into our net zero goals. Thank you so much, sir, for this enlightening session.
Can we have a picture together?
Yes, sir. Actually, we are having. Please switch on cameras, everyone. We'll have a group photo. Okay, thank you everyone. The photo is
Thank
done.
you very much.
Thank you, sir. Bye-bye.
See you.
Bye-bye. We can also leave now, Sankangsha.
If you have a further question,
No, sir.
you may email me. No
We have to
problem.
be online.
So now we will begin our another session by 3:30.
3:30. So we can have lunch now. 5 minutes break.
Yes, sir.
Yes, sir.
Okay, thank you.
Thank you, sir. Please, everyone, please fill the attendance link which is mentioned in the chat box, and we will resume our next session within 5 minutes.
Hmm. Good afternoon, sir. So your mic is mute.
Hello, good afternoon. How are you?
I'm good, sir. So we will begin our session by 3:30.
Sure.
So, sir, shall we begin the session?
Sure, I can. Shall I share my screen?
Yes, sir. So, before that, I will give a short, brief introduction about you, sir.
Sure.
So, now we are transitioning immediately to our session 12 of this 6 days FDP running from 3:30 p.m. to 5 p.m. This session serves as a vital conclusion, synthesizing all the core elements we have discussed this week. The topic is materials, methods, and digital innovation for low carbon infrastructure. Introducing are the expert, Dr. Sitesh Kumar Singh, sir. It's an honor to introduce our technical expert whose multidisciplinary background perfectly encapsulates the holistic scope of this FDP. Dr. Sitesh Kumar Singh is currently an assistant professor in the Civil and Environmental Engineering Department at the National University of Science and Technology, Muscat, Sultanate of Oman. His extensive experience provides a truly integrated perspective with over 9 years of experience across India, East Africa, and the Middle East. Dr. Singh holds qualification in the civil engineering, urban transportation planning, intellectual property rights, and urban planning. He is a chartered engineer and a certified project management demonstrating his command over the both technical and managerial aspect of the construction. His expertise includes the integration of artificial intelligence, data analytics, and smart technologies in the construction and transportation systems. Dr. Singh will provide the concluding framework showing how the innovative materials, efficient methods, and digital tools must coverage to the create sustainable low carbon infrastructure. Now, I invite Dr. Sitesh Kumar Singh sir to take the stage for the session 12.
Thank you so much for the brief introduction. Let me share my screen first.
Sure, sir.
I hope my screen is visible to all.
Yes, sir.
Okay. We'll start.
Could you
Good afternoon,
please
everyone.
share, sorry to interrupt you, could you please share this in the slide mode?
I think it is.
No, sir, not right now.
Now you can check.
No, sir. So could you please reshare the screen again? I think you have shared the particular window right now.
Yeah, I just share the window for this.
So could you please share the entire screen so that it will automatically convert it to that?
Sure. Now I hope it is fine.
Yes, sir.
Great. Okay. Good afternoon, everyone. I am Dr. Sitesh Kumar Singh, Assistant Professor at Department of Civil and Environmental Engineering, National University of Science and Technology, Muscat, Sultanate of Oman. And it is my pleasure to deliver the session on sustainable road construction, materials, methods, and digital innovation for low carbon infrastructure. Before I should proceed, I want to thank the management of NICMAR Delhi for conducting this fruitful FDP session. I want to thank Professor Nakul Garg for his invitation and Professor Rajesh Goel for this opportunity to serve as an expert for this FDP. This faculty development program is part of AICT's theme on, as proposed by NICMAR, on digital construction and green design pathways to net zero, hosted by NICMAR Delhi. So today we will explore how traditionally pavement engineering is evolving due to global climate commitments, technological disruptions, and India's accelerated infrastructure developments. And I will be integrating with this session as both academic and industrial concerning the audience from academics and industrial professions, And I will try to integrate with some real-life examples, some case studies, some Indian standard and international benchmarks, and some research finding to enrich this discussion. So let us start with my technical contents. The first, I want to share with you why we need a low carbon road now. As we know, traditionally, we are constructing road in different approaches since history till the date. But now, when we think about the carbon emission, we understand that the global transport sector contributes nearly about 23% of all energy-related carbon dioxide emissions, as it is highlighted by the Intergovernmental Panel on Climate Change in its report published in 2022. It says, road form a major component of this emission footprint, particularly due to the energy intensive production of asphalt binders and aggregates. India is currently implementing a massive infrastructure program, including Bharatmala Pariyojana, Pradhan Mantri Gramin Sadak Yojana, and PM Gati Shakti National Master Plan. With this rapid expansion comes a proportional rise in resource consumption, energy demand, and carbon emission. India says India's national pledge is to achieve net zero carbon emission by 2070. As we know, different countries have their different benchmarks to achieve their net zero carbon emission, and UN proposed for 2040. But understanding the situation of different countries, they had made their own target to be carbon neutralized or negative. And concerning to India, its target is by 2070. The road construction sector must urgently transit into a low carbon materials and methods. And citing this commitment, might be aware that plenty of recent developments in the researches for road construction has been carried out through various research institutions around the country in India to reduce the carbon emission, and where some stakeholders such as Ministry of Road Transport and Highways, Indian Road Congress, and the Smart City missions, which are increasingly embedding sustainability indicators in design and construction requirements for the future development of roads. So this was a quick short introduction. What I believe, like, at the end of the session, all the participants will be able to understand these all learning objectives concerning understanding the life cycle of a road and identifying the carbon hotspots. Then learn about low carbon material, including reclaimed asphalt pavement, warm mix asphalt, biobenders, industrial byproducts, and many more, exploring the energy efficient construction methods such as cold mix asphalt, which definitely have a low carbon emission, cold in place recycling, and then examine how the various digital tools such as building information modeling, life cycle assessment, Internet of Things, artificial intelligence, and digital twin can optimize the sustainability in infrastructure development, and identifying emerging opportunities in teaching, research, consultancy, and curriculum development, especially focused on the National Education Policy 2020. Road life cycle and carbon hotspots we will be discussing, where how the construction of roads and its impacts on the carbon emissions. A road's environmental impact must be assessed through a life cycle assessment as per ISO 14040 by 44 standards. Just sorry for interruption, just I will take a short break. Sorry, I'm back. Sorry for the interruption. So when we talk about the life cycles of a road, the life cycle includes raw material extraction, manufacturing of asphalt and aggregates, transportation to the construction site, then the process of constructions, then the operations and maintenance of a project, then end of the life cycle and its recycling. So there are some studies, such as through a researcher, they says that 60 to 80% of the total carbon footprints come from the production of bitumen and aggregates, followed by transportation and fuel-intensive construction processes. For example, construction of a 1 kilometer 4-lane flexible pavement in India can generate approximately 500 to 1200 tons of carbon dioxide or its equivalent, depending on the types of material we are using and the haul distance. This highlighting the importance of early stage interventions in the design for a road infrastructure project. We will be discussing now carbon footprints in Indian context, how Indian geographic and the logistic condition influence the road construction and emission of carbon dioxide. So long transportation distance for aggregates is a key factor. Hot climate condition requiring more energy intensive heating and high traffic loads leading to frequent rehabilitation, which are the key issues how the carbon emissions are being increased. So a landmark study by the Energy and Research Institute on the 20 national highway development projects, it says that the material and the construction phases contributes the majority of life cycle of carbon dioxide emissions. Well, for example, such as there are certain stretches, for example, in Delhi and Meerut Expressway, they achieved 50 to 20% reductions in the carbon emission while construction of the highway infrastructure project just by using a recycled material and improved mix designs. So this underscores the opportunity to adopt recycling, low temperature technologies, and optimized logistics within Indian projects. There are few environmental indicators which rely on the sustainability of pavement. So such as sustainability in pavement, we can assess using various indicators concerning environment, such as carbon dioxide equivalent emissions, then energy consumptions, we measure it in megajoule per ton of a mix, and the resource depletion, which is virgin aggregate use, then air pollutions refers to nitrogen oxide, then some particulate matters, then utilizing the waste material efficiency, how waste can be efficient for us. So there are certain tools such as OpenLAC, then GABI, and some data sets like EcoInvent are widely used worldwide. Even in India, agencies such as CRRI, Central Road Research Institute, and the Energy Research Institute have initiated some efforts to create India-specific life cycle assessment databases, which will greatly improve the accuracy for understanding the life cycle of carbon emissions through environmental indicators. There are such some case comparisons through hot mix asphalt, warm mix asphalt, then reclaimed asphalt pavement with addition to warm mix asphalt. Here it says that in hot mix asphalt, it produces at 150 to 170 degrees Celsius, which consumes a large amount of fuel and emitting significant carbon dioxide and carbon emissions. When we focus on the warm mix asphalt, it is produced at 110 to 140 degrees Celsius, and its certain benefits are such as it have 20 to 75% fuel saving according to a research, then 10 to 30% reduction in the carbon emission. It have lower fumes and better workability conditions. It have a faster paving window where we can pave the road in faster compared to another type, and it is most suitable for urban zones. And when we compare with RAP to WMA combination, we say that it used 20 to 30% reclaimed asphalt pavement mixed with warm mix asphalt. It have a reduced life cycle emission of carbon dioxide up to 30 to 45%. It cuts virgin binder demand, reduce aggregate, minimizing the impacts. Then there are some global examples such as according to the FHWA, which says US Federal Highway Administration and several European road agencies, they had a global practical examples on adopting these all cases. There are some overview of low carbon material which I will be discussing. So low carbon materials falls into few key categories, such as first, recycled material, where reclaimed asphalt pavement, then reclaimed asphalt shingles, then construction and demolition waste are some examples. Then the second factor or key category is modified materials, such as we can use rubberized asphalt, plastic modified bitumen for road construction. And if you take a few different categories, such as bio-based materials, we can use lining-based binders. Waste cooking oil is also a recent and very rapid enhancement in research using waste cooking oil as used as a bio-based material binder for pavement construction. Even algae-based polymers are also widely used nowadays. And then last category, I will say, industrial byproducts, such as fly ash. As we know, fly ash is the waste of a thermal power plant and some different power industries, which we can use as a for road construction. Then slag we can use, some copper slag we can use. So this all aligns with the circular economy principles, which is supported by the NITI Aayog's Waste to Wealth mission. I will give you some insights on recycled asphalt pavement, or we can also say it as reclaimed asphalt pavement. So just in a very short and a very general introduction, what is it about? Recycled asphalt pavement we refers like when we are refurbishing or reconstructing a road, then before you might have observed that the pavement layers are being removed from the roads. So that removed pavement layers, we can use it as a recycled asphalt pavement. So few proportions we can design with the different binder and bitumen and the pavement materials. So in this case, RAP is milled material of what we say, I say like old pavements, and it has plenty of good benefits, such as it reduces the raw bitumen consumption. So definitely we can say there are few sustainable approaches into it. Then it also lower the aggregate extraction. So in this case also, we are conserving our environment up to a certain extent. It even lower the landfill waste as the waste we are using in that respect. And also it reduces the haulage impact. So some literature shows that there are 15 to 30% environmental impact reductions using 20 to 40% of recycled asphalt pavement. Considering an example of Indian scenario, we can say Indian roads, as per the Indian Road Congress (IRC), it allows the use of recycled asphalt pavement, and even National Highway Authority of India has successfully used 15 to 20% of recycled asphalt pavement for the construction of NH48, which shows a strong performance against rutting and moisture damage resistance, which makes this road more strong and durable. Now I will give you a short insight about the warm mix asphalt. See, in warm mix asphalt, it allows the production at lower temperature using some techniques such as foaming techniques, chemical additives, and some organic waxes we can use. So there are some benefits such as it have a low emission on of the carbon dioxide, even it have low energy consumption for the construction process, safe working environment, long haul distance, better compaction in case of cold climate environment. So as per the Federal Highway Administration of USA, it reports that up to 30% of energy saving is there when we use warm mix asphalt. According to IRC, it has incorporated warm mix asphalt in IRC SP 101 manual, and even some municipal examples includes for the cities such as Pune and Chennai, which they implemented warm mix asphalt for their construction of arterial roads. There are some insights about integrating reclaimed asphalt pavement and warm mix asphalt. So in the case when we combine reclaimed asphalt pavement and warm mix asphalt, definitely with the enhanced technologies of with enhanced material property, they have a dual advantage, such as it will be having a lower production temperature, it will reduce the need of a raw or virgin binder, even it will improve the workability of aging of reclaimed asphalt pavement binder, even it have a better moisture resistance when we are using additives for making a bitumen mix design, and even it have a lower life cycle of greenhouse gas emissions. So according to European manual and example, the European trial achieved 40 to 60% of reclaimed asphalt pavement in warm mix asphalt mixes with the performance equal to or better than a raw or virgin mixes. So this is a strong research opportunity for India as well, due to the growing availability of reclaimed asphalt pavement, and as we know, India have one of the largest road infrastructure. Then I will be giving you some views on the rubberized and plastic modified asphalt. As we know, even it is also a widely used product. As we know, we have plenty of rubber waste and plastic waste, in which some specific kind of rubbers and plastic waste can be used for the construction of roads. So mostly we had seen, and even one of my research projects also had been used, the waste tire for a partial replacement of bitumen in construction of roads. So we can use the crumbed rubber modified asphalt, which is made from the end of life tires. When the tire retires, we can shred it, primed it into crumbed rubber, and we can make a good bitumen mix, which have plenty of benefits. We can say like using this kind of roads, it gives a unique acoustical property, such as when the vehicles are moving on the road, and as we know, when the vehicles are moving on the road on a higher speed, it generates some noise, right? So in these kind of roads, you can say there is a noise reduction up to 2 to 4 decibels, it have a improved fatigue resistance and a better skid resistance, as it generates more friction between the tires of the vehicle and the road surfaces. Even in plastic modified asphalt, due to the regulatory emphasis, as per we know, India leads globally in plastic modified asphalt. As per the Ministry of Road Transport and Highways circular, plastic waste must be used within a 50-kilometer radius of urban area for the preparation of a plastic modified bitumen mix for the purpose of construction of road. And even as per the reports of Pradhan Mantri Gramin Sadak Yojana, they had built over 25,000 kilometers of roads using plastic modified asphalt. However, some microplastic leachings and standardizations are required to study for a better binding. Now I will focus on my next topic, says bioasphalt and alternative binders. So there are plenty of biobinders which are widely used for the construction of roads, such as woods, algae, paper, lining-based binders, waste cooking oil, algae extract binders, bio oil from agricultural waste. And they have a plenty of benefits, such as it reduces the reliance on petroleum binders. So in this case, we can reduce the utility of natural petroleum binders. We may call it as a bit sustainable effort for road construction. We have a lower heating requirements for preparation of bitumen mix as with we compare to a raw bitumen binder. And in that respect, we can say we have a low carbon emission. Just a minute. According to a research literature, it shows some promising results using utilization of the waste cooking oil as a bitumen modified binder. Even a European pilot study says using lining-based asphalt, it demonstrates comparable rating performance for the pavement structure. Even in India, there is a massive WCO generation, which makes this a prominent avenue. Low carbon aggregates and industrial byproducts we can use for construction of roads in such a way that there are plenty of industrial byproducts which can improve the sustainability when these are used in the different pavement layers of a pavement structure. For example, we can, and even it is widely used, fly ash is the best example. Fly ash is one of the good binding material which is available in a mass in India, which is used for the construction of embankments. Then we can use granular blast furnace slag, GBFC, for the purpose of aggregate replacement up to certain proportion. We cannot replace 100%, but up to certain proportion definitely. Then even copper slag is widely used for bituminous mixes, and C&D waste are widely used for granular sub-based layer. According to MORT's specification, it allows these materials for construction of road infrastructure in India. And even Delhi-Mumbai Expressway has used a large amount of C&D waste aggregates in the Delhi-NCR stretch section. Now I will focus on the mix design and structural design for sustainability. So sustainable mix and the structural design mostly focused on the balanced mix design for optimizing the binder content. Then we can think about avoiding the over design to reduce the use of materials, and even designing the perpetual pavement to minimize deep rehabilitation cycles. According to, and even we can have accounting for local climates and the traffic conditions as well. So even with some studies, it says in United States and some parts of Europe, they have implemented perpetual pavements which last over 20 years with minimum requirements of the overlay when it is needed to be like reapplying of or repairing of the pavement structure. Now we'll discuss on energy efficiency of the bitumen plant operation, where we says that when we have energy efficient plant, then it have a huge saving at for the energy with respect to preparation of asphalt for the road construction. It says like in burner upgrades, it yields to 5 to 50% of the fuel saving for operation of plants. Insulated pipelines can reduce the loss of heat, and warm mix asphalt can reduce the requirement of extra heating demand, and even some AI and IoT based sensors can monitor the use of energy in real life plant operations. And even solar assisted drying systems can be helpful, and even in nowadays it is highly used and emerging technology in Indian context. So there are few companies such as Apollo and Amana India, which are now offering the energy optimized system for pavement or bitumen plant operations. There are few on-site sustainability practices for the construction of roads, which says that in on-site, we can significantly influence the carbon footprints by optimizing the truck routing, which can reduce the idle time, which can reduce carbon emission. Even intelligent compaction can achieve a density with fewer passes. Even on-site recycling can reduce transportation requirements. Preventive maintenance can reduce the material consumptions. So these practices can reduce the carbon emission, they can improve efficiency and increase the life of the pavement structure. We will be discussing now cold mix and cold in place recycling of pavement asphalt. So in cold mix asphalt, it is produced without heating the aggregate or the binding material. So in that case, it is ideal for rural and low volume roads, as even when we are constructing roads for the PMGSY Pradhan Mantri Gramin Sadak Yojana projects. So there, for this kind of projects, cold mix asphalt is ideal. It saves fuel and reduces emissions. Even I observe cold mix asphalts are widely used for patching or repairing the damaged pavement structure. As we know, if any pavement structure is being damaged, it is like uneasy for driving the cars and the traffics are disrupted at wide range, right? So in that case, when we need to repair the pavement structure, you are seeing like in a hot mix approach, the traffic are disrupted for a longer time. Like when preparing, it needs some time for curing, then it will be hardened and it will settle fast. But in case of cold mix asphalt, it is easy to construct or fill the voids or patch the roads, and you can open it for the traffic immediately after preparation of this cold mix patching in the road. So in this case, we can say This is one of the good, modern, and fast approach for road patching and even construction of roads as well. Now, cold in place recycling, it refers to the reuse of existing pavement on site immediately. So it will reduce the hauling of materials, and you can achieve 20 to 60% environmental impact reduction against the construction challenges or emissions to the environment as per literature. So there are some examples of Pradhan Mantri Gramin Sadak Yojana only. Like in Nagaland's Pradhan Mantri Sadak Yojana project, they had successfully implemented the full depth reclamation and cold in place recycling for the construction of these kind of roads. There are some core benefits related to health, safety, and society by using these all approaches and the different kind of bitumen and binding materials what we were just discussing, such as sustainability can align with environmental and governmental goals. So by this we can lower the fume from warm mix asphalt, which can improve the work of or the health of the workers who are working continuously on the site for construction of roads. Even it have a low noise surface, which can reduce the disturbance to the community or the society which is nearby the construction site, so they will not be disturbed. And we can achieve it using a rubberized based pavement asphalt. Even there are some approaches such as when we use waste materials, we recycle the waste material. In this case, we are reducing the waste, garbage, and pollutions from our society, and we are using it for the construction of roads. So these all processes have a good employment for the local society and the laborers from the local places. So it gives them an employment opportunity. In this respect, we can say these are beneficial for the society. Even this approach reduces the dust and the carbon emissions, which benefits the surrounding community so that they can have a fresh air to breathe in, and the less population, like pollution to the society, even through the dust. So these are certain core benefits which can increase the public acceptance and a long-term project value. Definitely, when we say long-term project value, we are not considering the economical benefits of the project only with the theme like how durable the road will be, how long it will last. Our focus should be in such a case that the multi-stage, multi-purpose societal benefits, not just for the, even we can say like when the roads are good, the transportation increases without disruptions, traffics are moving. So this is a societal benefit. But if you use certain approaches where the society can be benefited in various forms, these all approaches called as a sustainable and better approach for construction of roads, as just we discussed. Like if we are doing certain things which gives employment to the society, the societal benefits, safer roads, if there is no emissions or less emissions, a healthier society environment. So in these all respects, we can achieve our sustainability target towards the net zero emission by 2070 if we start using these all methods in highway development or road development projects. Now, the very imminent and most recent and the unique topic for the discussion is digitalization in the road construction. So see, in a traditional approach, what we are doing, like there is a specific road design plan which is being executed by the engineers and the contractors to construct a road, right? But there are plenty of modern tools and techniques through which the road construction is digitalized you can visualize how the roads will look like, and even you can monitor its progress, you can monitor its performance, even you can monitor in future if there is any maintenance required. So there are plenty of different technologies which we can use for digitalizing the road construction processes. So the first technology I will focus is building information modeling, BIM. So BIM is one of the unique tool or application which gives us an integrated design. And now, you know, like BIM modules are widely being adapted as a teaching and learning tool even in the educational institutions. And NICMAR is one of the best example how they are integrating BIM in their teaching and learning practices to train the engineers to make them industry ready. And even plenty of good institutions now they are using, and lots of industries as well, they are using BIM for a better integrated design. Even Internet of Things, IoT, are widely used, right? When we say IoT, it, we know this is a computing and electronic tools, but there are plenty of applications of IoT in our civil engineering perspective for construction of buildings or roads. Everywhere we can use IoT. So it is like a certain kind of integration of technologies with some sensors which gives us a real-time monitoring. And even the best example is like if you see the traffic responsive traffic signals, these are all integrated with IoT. Even you might have learned about there are plenty of intelligent transportation systems, such as example is one of the uh, companies there, Scoot, we say SCOOT, split cycle offset optimization techniques. So the Scoot has been implemented in one of the highways in India, which is fully integrated with plenty of sensors and IoT models, which gives a good traffic management for the operation of an expressway in India. So we can use IoT even for the construction time. Even when we are laying the bitumen mix design on the road, it will help us for accuracy of laying, and it will give us real-time monitoring of preparation, even the plant operation for the bitumen pavement design. So these all things, there is plenty of applications for IoT. Now, artificial intelligence is such a tool which we can use it for the optimization of bitumen mix and prediction of certain defects. So there are plenty of AI applications in which we can even use it for future prediction of pavement cracks. So one of my own ongoing research projects I'm working on to it, like how understanding the current situation and the traffic load, if we see any specific kind of cracks or damage or in the roads, we can use certain different approaches through photogrammetry or thermal scanning, and we can just put it on application of artificial intelligence to just visualize the future prediction, how these all payment defects will be increasing, how fast it will come. So we can prepare a periodic and rapid maintenance plan for better road infrastructure. Even geographical information system, GIS tools, are widely used for the spatial analysis of road construction. Even if you see the first step of any highway design, we say it as highway alignment, right? So when there is highway alignment, it is very precisely, you can do a highway alignment, understanding all the curves, counters, curvatures, and the different slopes, elevations of the proposed area where roads to be developed. So we can just identify or obtain the coordinates on the proposed route. We can plot it on the geographical information system, GIS applications such as QGIS. Then we can develop a highway route through GIS. which will give us the various contour points and levels by which we can identify where we need to fill the embankment, where we need to keep how much elevation, super elevations. These all, like, it is a very key tool which helps in the development of highway infrastructure project through these digitalization techniques. And there are plenty of different ways, such as you can say automation and robotics, though automation and robotics works with mechanized approach of Internet of Things and artificial intelligence. But there are plenty of applications uh, which have applications of construction of houses, even roads, through automatic robotic equipments and machines. So these all align with the vision of digital India and the smart city mission of Indian government. So in BIM, Building Information Modeling and Life Cycle Assessment Integration, we can say that this integration of building information modeling, which it have a great impact on the assessment of life cycle of a pavement structure or pavement infrastructure. It enables real-time carbon emission estimation by which we can just analyze what will be the carbon emission on the respect of our current design practices, which will give us an scope and opportunity to modify the design or carbon optimization procedure by changing certain proportions of bitumen elements and various mixed design operations. Even it helps compare material and mix alternatives. It will allow simulating of various maintenance strategies which are required for the development and construction of highway infrastructure. And the most, it supports optimize the design decision for development of highway infrastructure project. So according to a literature, it says that, which is published in 2022, it says that the BIM enabled pavement management system can reduce up to 30% of life cycle greenhouse gas emissions and up to 65% of the maintenance planning can be reduced. I will focus on some maintenance of payments, like payment maintenance system strategies for a carbon aware maintenance or low carbon, the maintenance system which will be focused on the low carbon emission, which is very essential for sustainability. As we know, certain roads which are being constructed in past and in current scenario when it requires to be maintained, now our all construction practices are focused on achieving net carbon zero emission. So which is essentially a key element for sustainability as well. So based on the conditions of the survey, the traffic loads, and the budget requirement, we can think of the strategy for payment management systems in a sustainable way. We can shift the focus of our cost-only decision with the cost plus carbon plus performance. Like we should not only think of investing good money to develop a good infrastructure. Now, when we talk about sustainable approaches, we have to do a brainstorming on how we can reduce the project cost and how we can reduce the carbon emission and how we can enhance the performance of payment infrastructure. So even there are plenty of videos I saw with the Minister of MORTH, Nitin Gadkari. They are like the way he is dedicated for integrating the latest technologies, innovative and sustainable materials for the development of roads. And even in plenty of his projects, we had learned that the cost of the complete project has been reduced to very much further. So like we can utilize that money in further development of infrastructures. That's why we are saying like in India, it is one of the highest growing road network development around the globe. So even we can have a preventive maintenance by which we can reduce the emission by delaying in a major rehabilitation. Then we can use some GIS-based technologies in pavement management system. Even there are key examples such as in some road projects in Kerala and Karnataka, they had been used GIS integrated pavement management system for prioritizing the task, developing the road infrastructure, and maintaining or prioritizing the maintenance activities. So even as an academician, we can include this payment management system using some advanced and low carbon technologies in our assessment and courseworks, so that our students can also learn this approach and they can be future ready. And now I will be learning or discussing about smart and self-sensing payments. So there are smart payments. We call it a smart payments, which means that the payment is embedded with some sensors. So what is the utility of sensor? The sensor will detect the strain in the payment structure. They will monitor the temperature of the payment structure. They will monitor the moisture on the payment structure and rutting and various kind of damages which may be predicted. So when we have the payment integrated with some smart technologies and sensors, we can easily develop a payment maintenance plan in advance, and by this we can do action for the payment maintenance, and we can reduce any future challenges or accidents which may cause due to the deterioration of the payment structures. So these technologies are considered as the future and life-saving technologies for the person or the motorist. Then this also transmit the real-time data with wireless networks to the companies who are involved in maintaining the road network, and the companies who had developed the road networks as well, and even the government system. So they are having a data in a periodic basis about the conditions of the roads to think on the development of pavement maintenance plan and the plan for the priority for maintenance and rehabilitation requirement. Even there are integrations of piezoelectric energy harvesting system to power the sensors according to a literature. And even IIT Madras is conducting an advanced research on self-power pavement monitoring system, which can be like power the sensors, the whole system, traffic systems, payment management systems, where there plenty of sensors are there. They can be self-powered through plenty of sources, and you can say sources refers to maybe solar energy is very basic and common, but when there is a continuous movement of the vehicles, from that wind is generated, it may be used as power. Then the frictions between the road and tire may be used as a source of generation of powers, and there are plenty of different approaches where IITs are working continuously, and various research centers in India and around the globe, they are working continuously. So these all can enable the periodic maintenance, which have a reduction in the utilization of material and even reduction in the carbon emission. Now, coming forward, I will be discussing about how digital twin is an asset for road in a current era, and it is a future technology. When we say digital twin refers to a virtual replica. It means the same infrastructure, but in a virtual way. So when we integrate the digital twin for a highway, so we can say a physical highway or a specific road network, it integrates plenty of things, such as the building information modeling data, the intelligent sensors, IoT sensor feeds, some traffic models, the data of weather, the payment monitoring system information, and some LAC models. And they have plenty of benefits of integrating digital twin for the road infrastructure, such as it helps in predicting the deterioration of the pavement. Simultaneous intervention requirement will be reduced. Then it can optimize the carbon footprint. It can enhance the digital, or it can enhance the decision making by digital monitoring of the road project. So like through digital twins, the project management consultant companies will not have to rely more on a physical visit of the roads or the project. So through digital twin, the replica of the physical project, they can monitor the progress of the project. They can monitor the standard and the quality requirement of the project. They can monitor if there is any expected challenges which is there in the project. So digital twins is considered as nowadays one of the best asset for whole infrastructure, not just for the road, what we are focusing on, even for the buildings and the construction of any civil infrastructure, it is a big asset for us. Even some European agencies and some highways in UK, they are using digital twins extensively for their all projects. And even in India, on a pilot project, Delhi-Jaipur corridor was one of the example where digital twins were used, and some specific smart city stretches for the development of a smart city plans. Digital twins are being used in India as of now. So now we are on the verge of concluding the today's session. So even these all topics, what we were discussing about how sustainability approaches in roads, payment infrastructure, and highway infrastructure can be integrated with various advanced computing technologies such as AI, IoT, and various sensors, digital twins, BIM. There are plenty of opportunities as an academician for integrating these all terms in our teaching and curriculum so that we can make our future engineers ready with the current and future technologies. So it is recommended that some institutions can go for some electives which may be similar to such as sustainable payment engineering, digital infrastructure, even as per the National Education Policy NEP 2020 of India, engineering curriculum is encouraged to integrate sustainability, digital technologies, some real-world problem-solving technologies. So this creates a strong opportunity for the faculty members to modernize their civil engineering program as well, as such as we can also introduce a laboratory module on reclaimed asphalt pavement and warm mix asphalt pavement. This helps a student understand the sustainability-driven material choices. We can integrate life cycle assessment assignments using some real-life projects, data, or some case study informations to calculate the carbon emission for materials, the methods of construction, and the strategies of maintenance which may be required. Even we can conduct some practical workshops on building information modeling and digital twin for highway design, where the students can learn 3D modeling, clash detections, digital quantity takeoff for the project. Even academicians can design some mini project where a student can use IoT-based payment health monitoring system, such as moisture or temperature sensors embedded in pavement layers for understanding the pavement deterioration pattern and making a better pavement maintenance system. Furthermore, an interdisciplinary approach, this course can be blended with as a civil engineer plus computer science, we can say, such as AI-based payment prediction or digital twin modeling, can significantly enhance employability and research exposure. Even if we focus about research and consultancy areas, there are plenty of high impact research and consultancy opportunities which are emerging in the area of sustainable payment engineering, such as detailed performance studies of biobinders, such as learning-based binders, waste cooking oil binders in India's hot climate conditions can be recommended. Development of India-specific life cycle assessment database for payment materials, including regional aggregates, fuels, and construction methods, can be explored. Creation of artificial intelligence and machine learning models for predictive maintenance using data for payment management system, traffic sensors, weather patterns can be explored. Even research and development for digital twin system for municipal and highway networks, integrating building information modeling, IoT sensors, and geospatial data with GIS technologies can be explored. Even formulating and testing payment sustainability rating framework, which can be similar to international tools like green roads, but tailored for Indian conditions, can be explored how we can go for it. Even consultancy opportunities with Ministry of Road, Transport and Highways, Indian Road Congress, Smart City Missions, World Bank supported infrastructure project for sustainable development and design audits and carbon footprint evaluations can be explored. So these all areas align with India's Prime Minister's Gati Shakti National Master Plan, which emphasize integrated planning, design, in digital infrastructure, and low carbon development. So thank you for the lovely audience. I believe that through this faculty development program, you have earned some new knowledges or you have revised some terms which you already know, or you got encouragement to use these all methods and technologies for your teaching and learning, or construction practices, or consultancy and research opportunities. So to summarize the today's faculty development plan FDP session, there are a few key messages I want to share with you, such as sustainability must start at the design stage, not only during construction. Using tools such as life cycle assessment can early helps on identifying the major carbon hotspots through which we can mitigate any challenges related to increasing the carbon emission. Even material innovations such as RAP, reclaimed asphalt pavement, warm mix asphalt, biobinders, industrial byproducts can significantly reduce both the cost of the project and the emissions of the carbon emission, and even encouragement for a better and healthier life to the society. Some construction stages involved like cold mix asphalt, cold in place recycling, full depth reclamation, intelligent compaction can greatly reduce fuel consumption and enhance pavement performance. There are certain digital tools such as what we discussed about BIM, building information modeling, Internet of Things, the sensors, artificial intelligence, machine learning, pavement management system, digital twins, and advanced life cycle assessment methods can enable smart, data-driven decision-making, long-term carbon optimization. Even India has a strong drivers such as the Smart City Mission, PM Gati Shakti, and various Ministry of Road, Transport and Highways and Indian Road Congress guidelines that supports sustainability road development and that encourages that all that stakeholders who are involved in infrastructure development should focus on these all recent and advanced technologies. So the final thought to leave with you, with all audience, is what one sustainability practice you immediately integrate into your research or teaching or a industrial or field projects. So I will encourage all the participants to think about this realistic adoption in their regional area or their institution. Thank you so much. Thank you so much for the time. Thank you for your attention. Now I can welcome any specific comments, questions, or reason specific challenges. And even you can feel free to reach out to my email address, siteshing@nu.edu.om, if you have anything which you need to discuss with me further or explore any specific topic in this context. Thank you so much. A few references are mentioned.
So now we are moving to our last segment of this session. About the question answer. So there are some questions in the chat box. So Mr. Revant has asked, in your experience, which construction method have the biggest impact on reducing embodied carbon during the project execution?
So when we talk about the most impacted approaches, even the cold mixed asphalt approach, I found when we are preparing this mix, there is no much heat evolved into it. So it reduces the carbon emission at a larger stage.
So sir, now let's move to our next question, which Mr. Arun Kumar has asked. How BIM can be used for highway construction?
Okay. See, building information modeling, BIM, can be used for highway construction. It is a part of design, you can say. You can design highway in such a way that you can integrate its design and to the building information modeling, and you can visualize it after construction, how it looks like. Even if you remember when I was discussing about the highway alignment. So, for a highway engineers, it is tough to finalize the highway alignment. There are plenty of challenges. Then even engineers predict, like after the construction of roads through this proposed highway alignment, how it looks. So in that case, you can utilize building information modeling to visualize how your highway should looks like after construction. And there you can get lots of challenges which are helpful for mitigating these all tasks. And then you can modify your design accordingly.
Thank you, sir. Like, I hope the doubt is cleared. Now, the second question is like, what are Ms. Akansha has asked, what are the most significant methodological challenges in the adopting new low carbon construction methods? Example, cold recycling, warm mix asphalt in the India, particularly when integrating them with traditional contracting models.
So see, in India, actually, when we are thinking about the particular challenges related to the different ways is for attaining the sustainability and reducing the low carbon. So in some aspects, the availability of material, sometimes it is a challenge. We cannot get the material which is useful for low carbon emission. In some particular cases, the adoption of methodology is not switchable. So this is also leads to challenges. So, and these are particularly specific, and even budget constraints also leads to designing the roads and adapting the methods, which may leads to sustainability approach and reduction in the carbon emission.
Thank you, sir, for this question answer. So now there is another question from Mr. Akash. Due to the higher need for maintenance and lower design life of the bituminous pavement, the construction of the concrete pavement will be rising in future. Sir, can they completely replace the flexible pavements?
See, we can say like we know construction of rigid pavement is highly encouraged and it is increasing day by day. But no, it will never replace completely the flexible pavement. And even specifically, for example, as the place where I am living, Oman, it is one of the hottest place where the temperature is very high. In whole Oman, there is no rigid pavement. 100% roads are flexible. So there are few challenges related to the temperature, which rigid pavement cannot resist the high temperature with respect to cracks and deteriorations. In that respect, these flexible pavements cannot be replaced 100%.
Thank you, sir. So, sir, there is another question from Mr. Raven. So, among these co-benefits, health, noise reduction, waste reuse, and ESG, which one offers the highest impact in low carbon infrastructure and why?
What uses noise reduction?
Yes, sir.
Can I see the chat box? Yeah, let me
Yes, sir.
open the status. In noise reduction, waste reuse, and ESG, while one of our highest impact in low carbon infrastructure. Okay. So see, these all factors are highly encouraged, like it is a benefit for for a sustainable approach for road construction. There is definitely waste reused, then ESG and noise reduction, and plenty of health benefits. But mostly we can focus on uh, like waste reuse have high impact on low carbon infrastructure. As we know, the more waste, there is more carbon emission in any form. Even if we are disposing the waste, it generates some carbon emissions. So in that case, if we are utilizing this waste and we are using as in through a sustainable approach, we are using it for road construction, then definitely it have high impact on low carbon infrastructure.
Thank you, sir. If anyone has any, so there is a two questions more in the chat box. Mr. Vikyat has shared. Where should the research efforts be most strategically focused to overcome the current technology or regulatory hurdles, and what steps are needed for the accelerated implementation of proven low carbon methods across the national highways network?
Such a big question. Let me read it. What should research? See, if in current situation, when we know like our traditional way of road construction, and even as a researcher, when we are researching on certain methodologies of road development and with some new technologies and additives, new materials, plenty of challenges we are facing. In some situations, due to despite of availability of experts or machineries or materials, we are not much focused in in-depth research. But if you focus on some specific research organizations which have they have plenty of funds for development of good road infrastructure projects, so there are plenty of technologies which they are using. Even there are some regulatory hurdles, as we know, government have their own set of criteria for development of any research, and even specifically how much carbon emissions you are focusing on through your research. But still, we can think about developing of low carbon methods and implementing through the national highway projects. Even more Ministry of Road Transport, they also bid for some projects where the researchers can collaborate with them to come with some solutions. So even the lots of sponsored projects, various institutions in India, they are working with modes to reduce carbon footprints and even integrate with lots of latest and modern technologies. So even as a researcher, I want to say you, like for all researchers who are here listening to me, even when you are executing any project of your domain, try to focus that your all projects should be having a limited or minimum carbon emission, or it should be focused on how your project is reducing carbon emission. Whatever research you are doing, you have to integrate with it. Like for example, why I mean to say, like even if you are looking for a opportunity in Western countries, they have a specific research assessment system. Whatever research you have did as of day, they will assess all of your research to conclude whether any of your research is conducted in such a way that it emits or it increase the carbon emission. So as a researcher point of view, they will not focus to hire you. So in that case, you should focus specifically how you can include with your technologies and enhance and reduce the carbon footprints. Thank you.
Thank you, sir. So, sir, there is another question asked by Mr. Anish. How can digital twins and sensors technologies be employed to track and improve the energy efficiency of the infrastructure material over their life cycle, contributing to the goal of low carbon construction?
See, when we talk about improving the energy efficiency of infrastructure material over their life cycle, contributing to goal of low carbon construction, mostly we are focusing on utilization of digital twins or some sensors or some technologies which we can employ with. For example, when we are preparing any specific what we say any specific methods of plant operations where we are preparing the bitumen infrastructure, so or preparing a bitumen mix, in that case we are focusing on such a specific kind of ways or methods where we can use some materials which have low or limited impact on what we say on the environment. Even this can monitor, and this all can play a transformative role in enabling low carbon construction as they provide us real-time data, and some data driven insights are there, like how construction material will perform over their entire life cycle from manufacture to construction phase while we are putting on the road, and through operation still maintenance. They can contribute in various ways, such as they will give you energy performance monitoring of temperature gradients, the moisture levels, thermal situations, then loss of energies, even life cycle carbon footprints they will give. Even it can reduce the energy of predictive maintenance requirements. So these are plenty of ways by which we can think of how this can be efficient and contribute to the goal of low carbon construction.
So, sir, the last question for this session is asked by Mr. Ajit. What specific digital tools beyond basic BIM are essential for integrating the performance data of the alternative low carbon materials, example, geopolymer cement, recycle aggregates, into the design process for the road infrastructure?
So, so if we talk about the digital tool beyond the basic BIM, there are plenty of software applications and tools which are widely used, such as MIM, we can say material information modeling platforms, which can give you a good mixed design data, having a good durability behavior. It compliance with, you can make it compliance with IRC or more standard. Even we can use digital twin for pavement material behaviors to understand the traffic load, temperature situations, moisture conditions, rutting and cracking progressions. Even we can use there's a tool called as advanced pavement design and simulation. So we can use such as Astoware pavement design, then CanPave we can use. These all are integrated with something similar to the digital tools such as building information modeling. Even we can use GIS also for road plotting and carbon mapping. There are plenty of different tools. Thank you.
Thank you, sir. So thank you, Dr. Sitesh Kumar Singh, for your insightful synthesis of low carbon infrastructure. Your talk beautifully connected the materials, methods, and digital tools and the life cycle thinking while highlighting India's growing role in maintaining mainstream low carbon roads. We also appreciate your work on binders, LCA, database, artificial intelligence, machine learning maintenance, and digital twin based solutions. So with this, we are closing this session. Before leaving the session, we request you all to please switch on your cameras for the screenshot. Thank you all for joining this session. Now we have a 10 minutes break, and again we will have an enlightening session of this FTP. So till then, please stay joined with us, and we will begin our next session, session 13, by 5 p.m.
Shall I leave the meeting?
Yes, sure, sir. Thank you, sir, for
Thank you
joining
so
and
much.
sharing
Thank
the
you so much.
enlightening.
Good evening, sir.
Yes, good evening.
So we are now transitioning immediately to our absolute final technical session of the 6-day FDP session 13, running from 5 p.m. to 6:30 p.m. The topic is smart solid waste management in the built environment. This is where the physical remnants of the built environment waste must be managed intelligently and sustainably, completing our circle of knowledge. It is a profound privilege to introduce our concluding technical expert whose career directly addresses the crucial environment challenges of urban living, Dr. Naveen B. Dr. Naveen currently serves as professor and head of the Department of Civil Engineering at the National Institute of Technical Teachers Training and Research, NITTTR, Kolkata, under the Ministry of Education, Government of India. He brings over 20 years of experience across teaching, research, and industry. His expertise is perfectly matched to the urgent need for sustainable waste solutions. His doctoral research focused directly on the assessment of leachate characteristics and geotechnical properties of municipal solid waste landfills, contributing to the reopening of the Mavlipura landfill in collaboration with BBMP. Dr. Naveen has published more than 90 papers and organized the first international conference on green technology and sustainability 2025. He is also an innovator, having developed the pile modeling design kit and secured MOUs with international partners. He is recipient of numerous awards, including the Sir Award, the IEI Young Engineers Award, and Sir M. Vishweshwari Award. So now I would invite Dr. Naveen BP to take the stage for session 13. So, sir, the stage is all yours. Thank you.
Yeah, thank you. Firstly, before starting, I should thank Professor Rajesh Goyal, Director of NICMAR, for inviting me, and also Nakul, the coordinator of this program. And thanks for nice introduction, Akshana. Thank you. Can I share my slides?
Yes, sir.
Is it visible?
Yes, sir, it's visible.
Yes, sir.
Namaskar. Is it my voice is audible?
Audible,
Yes,
sir.
sir, it's audible, sir.
Yeah, thank you. Today we are going to address very important topic, that is solid waste management, and your FDP has been aligned for the smart related. So I want to give a importance that now our Honorable Prime Minister has inaugurated this smart concept in 2015. Okay, and they have identified 10 cities. See why they have identified, why is it required to make them as a smart? Like if I want to give an example of Davangere, see Davangere is not a metro city, but now they are emphasizing under the smart city category, they are giving a lot of importance. Initially, even the road connectivity, even for the solid waste management activities, even the solar related activities, it was very less. But under our Honorable Prime Minister vision and mission of this, so now the Davangere city has been completely developed. So I will be showing you that, because we are not going to the smart city concept, but my talk is restricted to only smart with respect to solid waste management. It is one of the component. So if you want to make our waste management to handle this problem in a very smart way, what all the techniques we have to use, and really we are using this problem systematically in a realistic. See, so with this background, I like to go into the realistic problem what we are facing in existing. my slide is visible. Is it moving? Aksana,
Yes, sir.
can you, is this slide is changing?
Yes.
Yes, good. So before going to address the smart concept, first and foremost thing, you should understand where our India, what we call, what is the status? Is it required to apply the smart concepts there? Then if you are applying, first and foremost thing, you should understand what is the problem and how to address that problem. We have to keep it in mind. So if you see that this is the area which we have taken, it is in Mumbai. See, if you see this, it's in a completely slum area. And people are staying 1:6 in the unsanitary. They don't have even basic facilities. And it is in a metro city. See, why it is happening? See, the reason, if you clearly understand, you can see one of the byproduct of economic growth, industrialization, and population. Why suddenly solid waste becomes so high since 2012 onwards? Initially, it was not like that. Even Bangalore, they called as a garden city. But in 2012, suddenly in the Times of India newspaper, it called as a garden city converted into garbage city. See, Bangalore is called as a silicon. Lot of foreigners are coming, but still, why you got the title? The reason, because of mismanagement. So where we are facing the problem, whether we are facing really problem in the current generation of the waste, or whatever we have done the blunder mistake in past 2 decades or 3 decades, that's why we are facing the consequences. So we have to, before giving any solution, we have to go to ground level. You have to understand that where the problem has started. You may ask that waste problem suddenly it has arisen. No, since long time it is there. And waste problem is only with respect to Indian scenario. It is impossible. It is a global problem. See, if I recall, the smart city concept word was firstly derived from the Russia. Slowly it has implemented in India in 2015. So why? Because waste is a universal problem, not it's only with respect to Indian city. What so-called developed country or developing country, the problem is common is waste management. So I will address that every step one by one in our slide. So if you see our Indian statistics, half of the world's population live in cities, and in many developing regions, less than half of the solid waste safely disposed. See, you are generating almost 62 millions of tons. But in that, you are just, if you bifurcate, the plastic weight is in 62 is 5.6 million, biomedical is 0.17 million, and hazardous is 7.9, and e-waste is 1.5. See, in that 62 million, 50% just they are discarding in the dumped area. And if you see globally, India is the third largest waste generator after China and US. You may ask why their problem, why their incineration is more successful. If you want to give the address, see our food culture from India and developed country and developing country, it's completely different. There, the dry waste is more, ours is organic waste is more. But if you are trying to take that and implying that same technology to Indian scenario, that won't suitable, and it is not economical also. See, if you see the status of the municipal solid waste, see, this is a CPCBC report. It says that India generates 13% of the world, the total MSW. 1,50,760 tons per day. In that, only 30 to 40% of waste is landfilled. Then remaining, where it is going? And next question is whether this 30 to 40% is really handled systematically, like whether they are converting into compost. It is difficult. See, myself, I am in Kolkata. I can see that here the waste management scenario has not been implemented systematically. Even if you see in North India, where initially I was in Delhi and Gurugram, no. But if you see Bangalore, Hyderabad, Vellore, Chennai, they have waste management 2016 rules are nicely they have implemented when you compare to North or East India. See, still the awareness is required. I will be showing that slides in the coming slide, how because of our ignorance, how we are facing the consequences. So before that, we should understand in local bodies, we are spending almost 500 to 1,500 rupees per ton of waste. Out of 60 to 70% is spent alone for only for collection, transportation and disposal. See this you are spending 60 to 70% of the total money just for collecting, not for waste to wealth concept. Means you are not generating, not energy, not you are using for the 7R concepts. You can see why we are doing all this collection, transportation, disposal. 70% of money. How it is possible in 30% you can able to generate waste to energy concept? It is impossible. See, here our basic problem is lying. That's why we are hampering. We know the solution, but addressing the waste, it become like a huge problem, especially in India, because the collection, transportation, disposal, what we have practiced since 3 decades, to address that problem, you require several techniques. You can't go by single technique. To see that US and EU have the so segregated MSW using strict policies and advanced technology. The first MSW rules in 2000. If you see that in 2016, they have made it completely. Initially, it was MSW 2000. Later, it made it like a solid waste management guidelines 2016. If you see that carefully, each waste they have segregated separately, and they were discussing how to handle, what is the best technology, how to manage that, how to generate revenue from. They have discussed it. But in 2000, just generally they have written. But they have understood and they have made it a very stringent policies in 2016. Based on that policies, now National Green Tribunal have given the fine for every state who have not following the guidelines. So that guidelines I could have discussed in next when I get that opportunity to discuss on that MSW 2000 Solid Waste Management 2016 guidelines. I will tell you every points how they have drafted and each points how they are implication is done and each state how they are managing. But today my topic is related to smart, not on the policies. So I'm not going to discuss on that. When you see that Asian country has failed to develop the cost-effective collection and transportation model. See, this is the word I will be showing in my last slide, how to make this cost-effective. See what here they are mentioning, the cost-effective, because just 60 to 70% whatever we are generating, that money is going for this, like primary segregation, secondary segregation only. You may be collecting dry waste and wet waste separately. But when it go to the secondary or when it is going to the truck, they will be mixing. Whatever you have put the hard work, maybe you are doing mistake in the primary collection or street sweeping or in secondary. See, there is no proper model is there. We know that you have to maintain each waste separate bins. But however, you are maintaining, but after handing this waste to Paura Karmikas, there in that decentralization, some mistakes has happening. Because why? Lack of knowledge, lack of skills, and also uneven dumping of country, developing country in like India. So initially population was less. So what they used to do, whatever the waste they used to generate, just they used to go outskirt of and they used to dump. But now the population has increased. So the dump areas are coming next to our backyard. See, that is why you can able to see this. Lot of waste issues are coming because now you have purchased your land, but now you don't know what type of foundation you have to use because soil is completely contaminated. Instead of shallow foundation, now you have to go for a deep foundation with stabilizing concept. And the second thing, so if you see this with respect to year, it is keep on increasing. That's why I told you. Now, if you see the existing status of MSW landfill in India, landfills are landfill is mainly for to dump inert material. But what is happening without doing treatment, just they are dumping. It's almost 70 to 90% of waste they are dumped in the landfill. And you know, India, most of the landfill are non-scientific and non-engineered. So in urban India, it generates 62 millions of waste annually, and it has been predicted that this will reach to 165 millions in 2030. See, still if you are not applying 2016 guidelines, then this waste may trigger. And if you required huge land, so at present we are already scarcity of land. So where you will make the landfill? So and 43 millions of municipal solid waste is collected annually, out of which 31 million is dumped in landfill site and 11 million is treated. You can see this. This is the actual, the scenario, what is happening. See, if you see this, the landfill sites, you have total 35 states. In each state, you have number of dump sites. See, Andhra Pradesh, you have 124 dump site. There, the reclamation is done only one, and they are converted into sanitary landfill is 3. And if you see Arunachal Pradesh, total is 34. No reclamation has done, no conversion, dump site into sanitary landfill. See, Assam, 45, nothing has been done. Bihar, 130, see, not even reclaim. See, if you are not done, that is the reason you will be facing that contamination problem will arise. So now you can't go for a normal foundation because soil loses its shear strength. See, now Assam, okay, Chhattisgarh 7, 0, Goa 8, only one has done reclaim. Haryana 76, 26 in progress. Himachal 57, nothing. Jammu 55, only 2 has done. Karnataka 191, no dump site has been reclaimed. And Kerala, it is 41, dump site is not reclaimed. And Madhya Pradesh, it is 326. See, and highest, if you see the dump site, it is in Uttar Pradesh. It is 609. But only one they have reclaimed. Rest everything as it is. Total, if you see, it is 3,184. In that, only 234 is reclaimed. And if you see that dump site converted into sanitary landfill is only 8. See, this is the source as per the CPCB annual report 2020. See, you are just dumping the waste. But what is the biological? Why suddenly fire is happening? Who is putting the fire? There is no need to put the fire. See, as we know that waste contain moisture content. Because of moisture, different types of bacteria will come. And if you are just dumping and closing with a soil cover, will the solution will be solved? No. See, with respect to time, the degradation keep on going on. That's why if you want to understand, you have to understand the 5 types of mechanism is there. How each type of degradation, the different types of bacteria will come. Finally, you will get methane and carbon dioxide. See, as you go deeper and deeper, the temperature will also increase. So this is the thing. When it exceeds, automatically inside the degradation is taking place. Then automatically, because of the methane content, the fire has taken place. See, this type of fire, every metro city it has done. Like Mumbai, Dinor, biggest landfill, entire India. Next, Ghaziapur, that is Delhi. Ghaziapur and Okhla. I will show you because of this what all the disaster happened. Because I told you the mechanism, the various aerobic and anaerobic process that occur simultaneously inside the landfill generate enormous amount of heat, lead to initiation of fire. It means that as you go deeper and deeper, the temperature will also increase. So automatically it is an anaerobic. Anaerobic means there is no circulation of air. See, and that leads to automatically catch the fire from internally. I will make you to understand there are 2 types of fire. Suppose the fire happening from the surface, that you can able to manage. Suppose if fire is happen from the internally, it is a very, very dangerous. You can't able to control that. See, because of this landfill fire, as well as just dumping the waste on the soil or water body, it leads to contaminate the soil pollution, water pollution. You can see there, you can see they are throwing the waste on the soil, even the soil pollution, and also water body, they are just throwing. It leads to soil pollution, water pollution, and air pollution. The people who are residing here, they are affecting by the health issues. Whether my slides are visible? Whether my slides are visible, it is moving. Anyone can confirm whether my slides are moving?
Yes, sir, it's moving.
Visible, sir.
Thank you. Thank you. See, as I already told you, see, we have understood here the fire is happening. If you understand the mechanism, I will teach you here. You can see there are two types of fire will take place in the landfill. I told you. See, one is from internally, that is called subsurface landfill fire. And sometimes fire will take place from on the top, that is surface fire. See, this will be like MSW, heat will be generated. This is oxygen circulation. That's why I told you it's an aerobic anaerobic reaction will take place. Heat generates that leads to catch the fire. If you are able to catch this methane properly, that is called waste to energy concept. That you can use for the kitchen purpose. See, fire that ignite and spread it on exposed surface of the waste pile. That leads to wildfire, combustible material. See, this type of issues you can see every states, not only. See, we were talking about the fire. Whether I am highlighting only on Delhi? No. This type of problem happen entire world. I will show you in coming slide. See, in Ghaziapur also happen. Balaswa, Okla, Dinor, Urli, Bangewadi. So you can name the states. Every state, this type of problem has facing. See, if you see Mavalipura, this is the first engineering landfill site in Karnataka. See, this was constructed by Ramki. Myself was a site engineer in 2006. I was involved in the construction of this Mavalipura landfill. I was knowing completely how it was designed. Myself was witnessing till the project completed. I was there. Afterwards, I went to do my higher studies in masters. So it was the first in Karnataka to design, but still it has started in 2010. It is inaugurated. But within 2012, this Mavalipura was completely closed. The reason, because of mismanagement. It was an open window platform. It was not closed. And it was per day 600 metric tons of waste is to come only from the Bangalore north. It was difficult to manage to prepare a composting. Suppose festival time comes, the quantity drastically increases. Rain comes, you can't able to do composting. See, that will be completely piling up. So what will happen? And the machine we have brought, it is from Italy. So if something went wrong, you have to call that person only. There is no specialized person to repair. So this hamper, and finally what they did, because every day the waste is to accumulate. So finally they used to dump on the landfill and start closing that. That leads to contaminate the Mavalipura village water bodies. See, that was my research area. I have taken and I have done that. That physicochemical analysis of leachate, water body, and how to use this material for the geotechnical purpose. See, this is there. I told you there are two types of fire, surface fire and subsurface fire. Surface fire occurs on the landfill surface and accident, intentionally ignition will take place. But in subsurface, it will be happening because of the reactions. See, that is heat generation inside the subsurface. And easy to detect and monitor. But here it is difficult to detect and monitor. So if not controlled, they become more intensive and hazardous. Here it can't control. Because in surface fire, you can able to visualize where the problem has happened. But subsurface, It is happening from the inside. So the disaster is in higher side. See, if you see the case study of Delhi, see Ghaziapur, it established in 1984 and its saturation reached it in 2002. Waste dumped every day was 1,800 to 2,000 metric. The height of garbage is 65. Balaswa, it was started in 94. The year of saturated is 2009. Year also from 2000 to 2,200 metric. See, Okla, 1995. And the waste dump is 1,000. Are you able to see this picture? Are you able to see this picture?
Yes, sir. Yes, sir.
Yes, sir.
See, this is the Ghaziapur, which we told 65 meter, just 8 meter is different. See, can you able to see this within a day it has happened? No, it is taken almost 3 decades. See, just they have done soil cover something. So you can see this, the methane is coming out. With respect to time, the heat will be more, the reaction will happen, automatically the fire will take place. This is internal. See, similarly in Ghaziapur, it started in 2000. And when rain comes, the major landslide happened in 2018. Almost 2 people have died during this process of covering time. See, this is happened in the 2000, I think 16, Ghaziapur landfill. His father, they were going for a student meeting. Father is to on Saturday. Because suddenly, because of heavy rain, the landslide has happened, completely washed out. See, just they have ended in the. See, his name is Kumar. That completely they have collapsed. See, 2 motorcycle, even the car, everything got damaged. You can see the visualize how that disaster has happened. But still in Delhi, the problem has not resolved, especially with respect to air pollution, even water pollution and solid waste. This is the issue. You can witness. See, this is the Balaswa landfill. I told you it is started in 1984. It is located in northwest Delhi, and also 8 million tons of waste already accumulated. See, no one has put the fire. Automatically fire is taking place because methane is generating. See, that's why I told you, if you are able to capture this methane gas, that is a good. You can generate the electricity. But however, we have not able to do, and because reason is it's an unscientific. See, it has reached already saturation in the year of 2009 and it received the almost 2,000 tons of waste per day. And this fire has already reported every year, leading to severe environmental pollution and economical losses. And this fire is taking almost 10 to 20 meters below the surface. See how you can address this. It's a very, very difficult. So that is the thing. In 2016 policy, they clearly says, please segregate the waste. Don't mix. If you are doing that, what will happen? Even the good type of material will loses its resource value. Then you can't able to do the recycle redesign concept. The material will loses its originality resource. So that is the first and foremost thing. In 2016, they used to tell maintain at least 5 dustbins. Don't mix it. See, this is, I told you, Ghaziapur. See, till now, we were discussing about in India, we are facing this type of problem because it is our developing country. Let's understand whether this problem is similar in developed country also. See, you can see this. This is in Malaysia. This landfill name is Muscat. You can see because of heavy rain, that is the cyclone type, that is typhoon, as it leads, the landslide has happened. See, just they also done the blender mistake. Just they have taken the waste, they have done the soil cover without segregating. See, it's almost 13,000 to 16,000 metric tons of waste is already accumulated. So you may think that if you do the soil cover without segregation, the problem is resolved. No, only odor problem is resolved. But today or tomorrow you will face the consequences. See, that is the thing. It has happened here. Almost 270 people have died. See, this is another landfill located in Greece. Here, this landfill has been completely covered. See how it looks nicely, but they have not segregated it. In this landfill, almost 8 lakh metric cube of waste is already accumulated. Because of slope stability, landfill failure, the people nearby already lost their life. Now, another landfill we are able to witness in USA. See, this landfill failure taken place on 96, March 9. See, 1.2 metric million cube of waste is already accumulated. Because of catastrophic failed, they were trying to expand the landfill. This failure has taken place. See, another landfill, it has happened in Colombia. See, as you already aware that waste contain highest moisture content. It's about 60 to 70%. See, that's why in soil mechanics we have that total stress equals pore water pressure plus. If you are not able to remove the pore water, even any bridge, any foundation will fail. That's why they will make a seepage hole. So water should not, it should come outside. But here, nothing. So automatically pore pressure has developed and the failure has taken place. See, almost 1 million tons of waste was there. Within 20 minutes, it is completely failed and it is affected almost 1.5 kilometer. You can see this. Are you able to see this slide?
Yes, sir.
Okay. Similarly, this is another site, dump site. See, this failure taken place in February 21st because of heavy rainfall. See, I already told you, if water, you have not made a proper provisions to come out, the pore pressure will build up and automatically the failure will take place. The same thing. See, in this landfill, dump site, almost 2.7 million metric cube of waste was accumulated. See, 147 people have died who are staying nearby village. So next thing is, okay, now the failure is happening. So what all the technique you can apply to identify and to control? So in that case, if landfill fire is happening, you have to understand this assessment, quantification of site, waste characteristics, fire dynamics, intensity and frequency of the fire. This is the first step. Then next, you have to do the detailed analysis of waste material buried, depth of the fire and the waste ignition source. Assessing the existing fire, prevention and mitigation measures should be taken. Identify suitable fire preparation and mechanism. See, this type of research work CSIR NERI already doing. See, I told you this is the thing. First, you have to do the assessment study. Then fire monitoring plan should be developed. Once you detected early fire, then you will be doing all the preventive measures. And also future preventive actions you will be taking care. See, when you are talking about assessment, it means the type of waste, waste receiving capacity, waste composition, waste topography, slope, edges, ambient temperature, annual rainfall shall be examined. Assess the landfill site, potentially for occurrence of landfill fire. See, if you want to do any analysis with respect to waste, see, waste is an heterogeneous property. So you have to use different seasons and you have to pre-monsoon, post-monsoon, everything you have to analyze. And also you have to take the climatic condition, wind and weather. That can increase the health hazard for the firefighter operating on the fire ground. And also the frequency of spontaneously smoldering and the fire event of emergencies are more prominent during the pre-monsoon because the temperature is very high. So it is easy to catch. So during the elevated temperature level. So you should detect this type of situation in early and you have to give a proper preventive measures. See, it is doing that. They are detecting, they are observing. See, this is the detection. See, this is the research done by the CSIR NERI under the Professor Sunil. See, his PhD scholar is doing this. They are inspecting the landfill site by putting the sensors. They are able to measure the carbon monoxide and landfill square temperature, surface temperature. See, they were doing regularly, daily during the pre-monsoon because temperature, it will be fluctuating weekly during the post-monsoon. Deep-seated surface fire shall be monitored by drilling the monitoring well in and around the suspected fire zone. And also the special attention should be given in the pre-monsoon period, especially there the temperature is almost more than 45 degrees. So there it's a very crucial to catch the fire in that time. See, you can able to detect and you can able to predict it. What is the status? What is the... See, this type of research technique applying in the Balaswa dam site, Bangewadi dam site. See, something you have to understand the guidelines in which temperature it will be good. See, if it is less than 40 degree, safe, not susceptible. 40 to 60 waste shall be treated as a safe for spontaneous smoldering and ignition, and 60 to 70 degree risk of, see, this is a giving a guidelines. If it is more than 70 degree, risk of spontaneously, it's a very high of catching the fire. See, same thing, it is expressing in the pyramid form. The temperature as you go from 40 to increasing, it is always, it will be a high risk. So you have to, so how to address? So the simple thing is, don't mix the waste. Segregate it, apply 7R concepts. I will be teaching you what is 7R in coming slide. See, you have understood the methane. Similarly, if you see the carbon level also, as you go from top to bottom, the carbon level also increases from 10 ppm to 500. See, this is all trigger to catch the fire. Same thing. See, now you are understood the problems. Till now we were discussing about problems, but you may ask, what is the solution? The solution means you have to maintain effective solid waste management plan, like segregate the waste, and segregated waste should be handed over to the Paurakarmikas. So you should not mix that recycle, plastic, food, paper. It should be properly, and it should be taken in the closed truck, not in open truck. See, open truck, what will happen? It will spill out. See, when you are taking to the landfill, you should have a lab. You should keep on monitoring. After doing all the treatment, only inert should go to the landfill waste. Are you able to see my picture slide? Are you able to see my slide?
Yes, sir.
Is it changing?
Yes.
Thank you. See, if you want to maintain an effective solid waste site,
So they all are able to understand.
could you please unmute? Could you mute it? See, you will be collecting the waste, then you are transporting, then disposable in such a way that it should not harm the environmental. And it should be taken in a closed vehicle. See, I told you, you have done nicely segregated, but when you go to from primary to secondary, see, this is the mistake happening. They are mixing it, and they are, instead of going for a closed truck, they are going by open. See, whatever you are doing, it is spilling out. It is creating a nuisance in the road. And also just they are dumping the tires, rubbers in the ocean. And low-lying area, just they are dumping the waste. Even you are going to office or traveling, after drinking the water bottle or juice, just throwing out. Because if you feel that it's an empty area, the thing is, you should have your self-responsibility. So when you call disposal, you have varieties, like you can do the burial, burning or recycling concept. See, incineration concept is there, composting is there, recycling waste concept is also there. See, now you have to understand what type of waste you have majority, which technique you want to apply. You have to think wisely and you have to implement. So we should not do any, okay, in US, they are doing incineration. So I will also do it in India. It is impossible. Already this type of mistakes they have done in Delhi. They have installed incineration, but later they've understood this technique is not appropriate for Indian waste. So if you see, our ancestors already implemented and adopted only single technique, that is called composting. Maybe a vermicomposting, biomethanization. Now you have varieties. If you don't have space also, you can do pot techniques. So you have to implement. The reason we have 60 to 70% is food waste. The food waste, it is easy to handle because water content is more. If water content is more means odor problem will arise and also bacteria will come. So what is the problem we are facing? How to apply this? How can we manage waste better? How to prevent the waste generation? Just apply 7 hours. You may be heard 3 hours or maximum 5 hours. I think first time you are hearing 7 hours. What is 7 hours means? 7 hours means before starting, you rethink. Now you are going to purchase milk. So don't go with empty hand. Take your own bag. So you are thinking there. So there you are cut down the plastic cover. Once you cut down that, then waste refuse will be stopped. Whatever you have that you are trying to reduce, you are reducing that. Then reuse, recycle, then regulate. Regulate means your policies. If you are not following, now 2016, they have started putting the fines. See, all these regulations will come. And every day the research is happening. New technique is coming. So research. So this is the 7 hour we have to implement. Rethink about our habit, our need, our basic requirement, reducing the waste generation, repairing, reusing, resharing, refuse anything that will harm our environmental, using something again or more than one time. Reprocessing of unwanted material into new useful production, regulate. See, if you are not putting any conditions, fines, we know that we are not so matured enough to implement. So it is a mandatory now. That's why to control, to make the things to happen, it is a mandatory now. Then research. Every day you are coming out with new innovation way to solve the waste problems. See, initially it was like that. Once you apply 7 hour concept, see, then it become new bottle, then it become new jar, then finally fiberglass. From newspaper, you can do several things. I'm telling you, if you take any material, if you apply 7 hour concept, it will be useful. That is called waste to wealth. And also, I told you, whatever we are doing the blender mistake. See, we are throwing the waste on the soil, cow, birds are eating, and they are leading to face their health issue. See, we are throwing the plastic cover. Aquatic animals are suffering. So please don't do that. And people staying nearby these landfill sites are facing health issues, asthma, cholera, like this. So that's why we come up with a technique called smart city, smart world. So the main thing is, whatever we are seeing, we know the solution, but we are a little bit lethargic attitude to implement. See, you have to tell to next contractor, he will go to tell to commissioner, implement. It's a lengthy process. Like how everyone can work together by applying these smart techniques. That's why smart manufacturing, smart governments, mobility, Wi-Fi, smart digital citizen, open data, smart health, everything. See, in one place, in one app, you can able to monitor, you can give the proper guidance, you can properly monitor everything. See, that was the vision of our Honorable Prime Minister. The objective of the Smart City Mission in India is to promote sustainable and inclusive city with core infrastructure to give a decent quality of life, provide a clean and sustainable environmental through application of smart solution such as data-driven traffic management, intelligent lighting system. See, these are the core infrastructure element in the smart city included. Adequate water supply, assured electricity supply. See, everyone is required now. It is not only people who are residing in metro city should enjoy all this facility. No, it should be done for equally. That is the objective. Everyone should enjoy the benefit. Sanitation, including solid waste management, That's why all this, you can see all it is happening in Swachh Bharat Abhiyan. Initially, there was no toilet. Now every village you can able to see. See, because this leads to health hazards. There will be no safety. Now you can see how efficient urban mobility and public transport, affordable housing, especially for the poor, robust IT connectivity and digitalization, good governance, especially e-governance and citizen participation, sustainable environmental, safety and security of citizens, particularly in women, children and elderly, health and education. See, also the same thing we are representing in university level, also sustainable goal 6, all this. See, that is also water related, wastewater related, how you are doing all this in your campus. That's why they are appreciating, they are giving a lead certificate for the universities. Because once you implement all this, it is helpful for the society, for everyone. See, also, if you apply this, what is the objective? It's an improvement, city renewal, redevelopment, city extension. Because of population, now you have to do all this. It's mandatory. See, administrative section, if you see administrative, National Apex Committee headed by the Secretary of Ministry of Urban Development, State High-Powered State Committee to be headed by the Chief Secretary of the State, City Smart City Advisory Firm in all smart cities, comprising the District Collector, Chief Executive Officer of Special Purpose Vehicle. This is the flowchart they have done and it is working very nicely. And also in Cabinet Decision 20th August 2024, our Honorable Prime Minister, this has been come out. It's a grand necklace of the industrial smart city. Industrial nodes to act as a catalyst for achieving 2 trillion to export by 2030. Cities to be developed as a greenfield smart city of global standard, built ahead of demand on plug-in and play and walk to work concept. Project to feature multimodal connectivity infrastructure, ensuring seamless movement of people, goods and service, provision of developed land parcel ready for immediate allotment, making it easier for domestic and international investors to set up manufacturing unit in India. Also, the end this indirectly or directly, the creation of 1 million direct and up to 3 million indirect jobs been through plant industrial. See, if you are applying all this smart city concept, you are able to generate jobs also. See, this is the physical infrastructure like compactness, solid waste management, assured water, smart housing, smart mobility, population, and also strategic component like city improvement, city renewal, city extension. So this concept now we are narrowed down into only to the waste. See, the first and foremost thing in waste, if you are applying a smart concept, means what? The objective is to recycling. First and foremost thing is, even you are not aware about, just you are dumping the waste and going. Whether that bin has been overflowing or whether it is empty, no one is ready to monitor. Every day the vehicle will come, whether it is empty or overflowing, he may come, he may not come. So it is difficult to track. This leads to waste the energy, petrol, unnecessary. If that in that area, if there is no sufficient quantity of waste is not collected, also you have to go. It's a dead kilometer, that called. So how to address this problem? So that's why we always use this multidisciplinary approach. So waste management, see, you're studying in civil engineering. That's why our NEP 2020 shows multidisciplinary approach is always best to solve the problems. See, you are with help of this computer science, specialized artificial intelligence and IoT, you can able to solve this problem. Reads the tag, determine the types of garbage and send it to the main server. And also the main server compares the various of garbage category and picks an appropriate disposal or recycling method. The safe disposal or cleaning recycling of garbage is carried out. See, You are just putting, you have prepared, it will go this to the concern, then artificial intelligence been increasing, utilizing in waste management to optimize the process, improve the efficiency, and reduce the environmental. See, this concept's already in developed country, like Russia, US, they have developed their own app. In India also, from Kerala, one of the company, they already started. They are giving this demo to the government of Karnataka. It is going to implement shortly. So this is happening in India also, but it should go to every state. See, this is the thing. Sustainability, recycling concept should be done. See, initially, instead of doing manually, even robots are able to segregate because it have given that different types of thing. They will segregate because this type of concept applicable for this big heap like Mavalipura, Ghaziapur. That's why they already told the sensors. It will able to identify and it will segregate. This problem, it will be applicable for the UG, like Dinor landfill, these things. See, automatic sorting, AI-powered tools and robot machines used a computer vision and machine learning to identify and sort the different types of material in waste streams. This enhances recycling efficiency by reducing the contamination and increasing the purity of recycled material. And also the smart bins. See, smart bins, you are applying IoT technique to detect the type and amount of waste being deposited. That data can be used for real-time monitoring, optimization of route, and promoting the efficient waste management practice. See, this is the predicting. See, once it is done, that will tell that, okay, in this route, this dustbin has been filled, this type of waste. So that type of vehicle will go and they will collect it. See, it will, all sensors are there. It will identify how, this is called optimization of route map. The signal will go to that, okay, this is maybe a medical waste, some places may be a food waste. It will go, what type of waste it is filled, the vehicle will go and it will collect the respective vehicle. See, recycle facility management. AI is used to optimize the operation of recycling facility. This includes monitoring the machinery, automation process, and ensuring the efficient process of recycled material. And also AI to analyze the market trends and demand of recycling material, helping the waste managers to organize, to make informed decision by recycling programs and initiative. See, this is called waste to wealth concept. See, I told even the problem is not for the fresh waste. The problem is identifying the illegal dumping. For that also, this is artificial intelligence. If you do, all information will go to black box. See, this is the lack of informations. If you get this, then we can able to address this. See, this is a smart bins with a real-time monitoring. Smart bins are fitted with ultrasonic or weight sensor that continuously measures how full of dump. When the bin reaches to certain level, it sends a real-time alert to the waste management authority, ensuring immediate. See, they will come, they will collect it. They will come to know that, okay, type of waste, wet waste, dry waste, or recycle. They will send the vehicle accordingly and they will keep doing. See, this is the sensors chip they are, and it will go to their mobile. It will get pop-up. The driver will get alert. See, it's all collected, all this information in cloud, and it will be giving information to. See, this is applicable to every health, manufacture, every places. See, while doing, what will happen? You are reducing the cost, collection cost, no missed pickups, reduce the overflow, waste generation analysis, you will completely know, and you can generate the waste to energy, and you can sell that electricity also. Myself has quantified for the Bangalore. That paper is also available. You can read that. We have done the carbon sequestration also. See, though so many techniques are there, you can utilize optimization of waste to energy. Artificial intelligence is applied to waste energy to optimize the combined process and energy production, waste to energy conversion process, improve this smart waste management city. Like AI powered platform provides the centralized system for managing the waste related data. This includes real-time monitoring, analytic reporting to the enhanced decision making for the waste management authority, and also application, AI application engage the public, providing the information on proper waste disposal practice, promoting the recycling, and encouraging the sustainable behavior. So you can see this now, especially in metro city, especially in Bangalore, person who is purchasing the flat, they should show the how they are handling the waste in that community only. It is a mandatory for them to use some techniques, whether it is an aerobic or anaerobic or pot technique, organic waste converter, they should set up like how the security guard will be there. For waste also, they will identify one space there. Whatever the waste they are generating, they will do the composting. They are not depending on the municipality now. From there, the manure what they are getting, and that will be used for their internal plantation purpose. And also the life cycle assessment can be done. See, here it will help you. AI assist in conducting life cycle assessment of. This includes evaluating the environmental impact of different waste disposal method and guiding the decisions towards more sustainable practices. And also we face some challenges like cost implementation. Initial cost of implementing AI technologies in waste management can be barrier for some municipality and organization. Data privacy and security. As with any AI application, the collection and analysis of data in waste must be adhered to privacy and security standards. And also integration with existing system, integrating the AI solution with existing waste management infrastructure and system may pose challenges and require careful planning. So I told it should be properly planned. And also you are using advanced sensor technology like IoT devices to contribute more accurate and real-time waste data. Robotics you are using for the waste collection. Okay. So if you are using robotic, it will increase the efficiency, including autonomous vehicle and drones for more efficient and automated process. And also, finally, the circular economy focus. AI will play a role in optimizing the waste management practice to support the principle of circular economy, including increasing emphasis on recycling and waste recycling. See, when we are talking about IoT, it's have its own benefit and some limitations. See, this is the benefit: efficient collection. Bins are emptied only when needed, preventing the overflow, reduce the fuel consumption, and also you can able to smart route, minimizing the vehicle use and emission, cost-effective operations, better manpower and fleet management, better hygienic you can maintain, enhance the recycling rate, and also improve citizen experience, scalable and consumable. But when you are applying IoT in waste management, you may have some challenges like I told you, network connectivity in remote areas, data security and privacy. For that, you have to secure it, cloud storage, encrypted by the device communication, and also integration with legacy system, custom APIs and middleware solution for smooth transition. With this, I am closing my presentation. The final proverb is waste never waste. Swachh Bharat India. If you have any questions, I'm happy to answer.
So sir, now we are moving to our Q&A session. So if anybody has any doubt, so you can use the chat box or you may unmute yourself and ask the questions over here.
It was so nice to have, in fact, Dr. Naveen. He's given insight to use of robotics for waste management and all. But imagine what the robots can do. And don't you think that it is too primitive a stage for robots to come in when you already have 150 robots moving around? So what and how can you in fact make that civic sense actually get into our heads so that these robots, they should not be overpowering our minds. and we should be, in fact, doing something which actually we are supposed to be doing as citizens of this country. And yes, how much, sir, the question to you is, how much have we made progress as far as, in fact, the robotic way of with the waste management in our country? Because I'm actually presently, though, in fact, I'm a civil engineer myself. I have spent almost 28 odd years in the army. And we not seen in the army as far as the robots are concerned. But yes, presently I'm working in the health sector. So we do have the robots performing operations. But now,
but not waste management.
But still, sir, I think it's a very new thing. Actually, it has come to fore that robots doing, in fact, segregation of waste and such like thing. So, at what level are we as far as this particular thing is concerned, sir?
Sir, as I told you, see, if you see that 2000 MSW 2000 guidelines, it has taken to upgrade and implement all this segregation, making that 7R concept which I was telling, it has taken 16 years. It has taken. See, you also know, I am also know everyone. See, this waste problem we are facing from long time, but we know that our basic fundamental is food waste, because we Indians always like more organic food, like fruits, other things. So the simple thing, instead of depending on incineration and other technique, the simplest technique is go for a composting. But instead of that, we are trying to do applying incineration. If you are going for incineration, you should have high calorific value, because our food waste don't have that high calorific value. So you can't able to make that incineration concept success in Indian scenario. But in developed country, it is there, because their food culture is completely different. 70% is dry waste and 30% will be organic waste, but ours is. So, and coming to this, which we are trying to say, this robotic, see now even NEP 2020, multidisciplinary approach is mandatory to solve the problem. See, one of my photo I was showing you, the waste what we used to tell, it is not in a closed manner, it is not segregated. Somewhere just some person will tell or give a phone, he will diverting his route according to his own style. See, we should not do that. That's why I told you IoT concept should come, optimization of route map. You have to identify the bins with the sensors, and it should be properly monitored. See, for each waste, you should maintain different vehicles. See, when it is filled, that much quantity, automatically that signal should go to them. They will, the automatically like route map will be prepared by that. The driver can go. Otherwise, suppose if I want to go, because in Bangalore, if you want to go to city market, they will go entire, instead of 30 minutes, they will take 1.5 hours roaming here, and because some person is influencing, hey, come here, first you collect, then go. See, it should not be done, unnecessary, because this type of things should be cut down. That's why this artificial. And also the major problem what we are facing is, you are witnessing that Ghaziapur, Mavalipura, this type of heap, there, if you can implement this artificial intelligence robot to segregate, but already we are doing with the help of biomining concept. Their objective is to segregate that waste, utilize that waste material with 7R concept. There you can able to generate the waste to wealth concept.
Like said, the waste, if you look at it, 11,332. I was just now, this generation is quite used to, in fact, using Chat GPT. So now even with me also, I got into the habit of using it. So I was just scanning through. I found the MCD, the daily generation of the waste is something around 11,332 tons per day. So,
sir, I told if one of my slide I already predicted, yes, for 2030 if you are doing, because one slide as a civil engineering calculate how much area is required. If you are doing this type of blender mistake, it will go 165 million metric tons something calculated, and also you required 44 acres of land in coming days. You already scarcity of
to be on the
space.
lighter side, to be on the lighter side, since in fact you've done a very serious lecture. Now point is Delhi at some stage, in fact, there used to be mountains around. Now, these mountains have been have taken a different shape altogether, and you are surrounded with mountains of waste.
That's right. And See, I told I myself I'm working on that related. Na? LPI concept we have developing water quality, and myself is a geotechnical and geo-environmental. I should address this problem in multidisciplinary, not only in environmental perspective. We have to address this problem in geotechnical. See, you may be addressing a waste problem. Next question is, you have spoiled the soil, you have purchased the land. Now you can't go for a normal foundation. The next thing is, at what depth you have to rest the foundation. Whether you have to go at shallow or a deep, in deep also what type of foundation, how to stabilize the soil. Again, it's a geotechnical problem. That's why a new wing has been established. That is called geo-environmental. So you have to see this problem. That's why who is designing the landfill, not only environmental people will do. Now geo-environmental who can have the knowledge of soil plus waste, they can able to interpret it, they can able to design that landfill.
Thank you so much, sir. Thank you.
So the next question was, what about industrial waste such as red mud, fly ash, etc.?
No. Today our topic is municipal. See, red mud industry. See, I told you it's clearly mentioned in 2016 for each waste it is there. So today I'm talking only on the municipal related.
Okay, sir. And
see,
next question,
every material I told now, if you apply 7R concept, every material can generate 7R concept and end up the byproduct is waste to wealth or waste to energy. So whether it's an industrial waste or whatever the thing, it can be done. So how to do, which technique is good, it is mentioned in that guidelines.
Okay, sir. Next question was by Chetan More. And sanitary landfill design analytical study, that is study of hydraulic conductivity, is required on existing sanitary landfill of that city before going for the design of new sanitary landfill in that city. Because currently in design, we only consider maximum saturated hydraulic conductivity 1 into 10 raised to minus 7 centimeter per second. So can you kindly put more light or give your view on that?
See, I told you, this is all theoretical. See, this is all the standard thing. We know that when you take the cross section of landfill design, what they are telling, the clay -7, what they are telling, hydraulic conductivity should be maintained, and the thickness of this. No? See, today what I am talking is the smart city concept. See, everything will come under the landfill design things. See, if that problem is there, we have to see that bore log, soil, complete soil profile. I want to understand how much waste is generated. Then we can able to debate what Chetan is asking. See, that is already given in the guidelines. If you are going, you have to maintain the clay with that 30 centimeter, and that permeability is a -7 centimeter per all this. So, but each case, site to site, it will be different. You should understand soil profile and you have to plan.
Okay, sir. Next, Bharat Jindal sir is asking, can any robot is in practice which can collect the sample and investigate the composition, etc., maybe from the places which are inaccessible?
We have to do that. That is the thing we are making to, like drone we are doing. Myself was planning to implement this because doing the survey of entire the big landfill, it is difficult to travel. So you can able to check that how much area that is there and what is the depth you can able. See, now we have to implement, we have the techniques. That's why we have robot, we are telling that IoT waste bin concepts are there. See, we have to start, it's a very starting. We have to practice it. For that, you require a skill and you require a specialized training. And when you are handling the waste, it is not like a soil. Waste is an heterogeneity, so you can't predict it. When you are standing on that, anytime it may settle. So myself, when I'm conducting a geotechnical or geophysical testing, it's a very difficult. So bringing the robotic, making all this, it's in a practical application. This all the technique, it can be implemented, but you have to start now. It's a very starting stage.
And so next question is, why are we lagging in waste segregation, and how only government can only change this waste mismanagement, which is turning into piles, mountains of dump across our nation?
See, government has not done. See, it is our basic. See, we are creating the waste. That's why government has that they are cleaning our waste. The first and foremost, to solve this problem, we should educate ourselves. It should be started from our household level. See, we have to educate. We should try to stop giving the waste to the municipality. You are generating the waste in your kitchen. You try to create the manure there. That's why we have a pot technology. And that's why I told you the example of Bangalore. If you have a 30 or 50 houses, we are not depending on the municipality. We have our own composting plant inside our flat community, and we used to do the treatment there itself only. We have a separate only dry waste. The vendors will come, you are handovering that and you are selling there. And from there, you will be generating the revenue from that. See, that is a waste to wealth. The manure which you are generating from the organic waste, you are using for the plantation purpose.
And so next question was composting. We have greenhouse gas effect. How do we solve this problem?
Yeah, everything I told now, the first and foremost, the basic is segregation only. Once you start from that, everything it will control. When you are not sending waste to the landfill, why this greenhouse gas concept will come? The greenhouse gas concept, methane, carbon dioxide will come when the waste become a very huge pile like a Ghaziapur, which I showed you. You try to address the problem at your household level only. So once we start educating ourselves, the objective of giving the presentation showing 7R is don't depend on the government, try to depend on yourself, educate yourself, that's why I told you, rethink, reuse, redesign concept. It should start from ourselves. So government is there to manage the show, we can't put all blame to the government. See, we should have a matured enough, we should handle this at our level. Because government is there, they are taking our tax and the tax money is wasted just for cleaning the waste. So instead of that, if you save the money, the government can use this money for the different infrastructure development. That's why I told you 70% just we are spending money just for collecting. See, in 30%, what you can do? So that's why we should stop spending money on the collection and this. How it can be done once we become aware about ourselves, what we are doing, where we are doing that mistake. If you correct at our level, then this price will be cut down. Okay. Any other questions? Or it's over?
It's over, sir.
Anyway, you have my number, email ID. If any participants wish to contact, they are happy to contact. I think I will share you my website. They can read a lot of articles, interviews on this waste management. So it will be useful for the participant. I was happy that at least they were able to follow my presentation nicely. Thanks for their time.
For providing such a crucial as well as conclusive session on smart solid waste management, which perfectly closes the loop on our commitment to a truly sustainable built environment. Your work provides a very clear and necessary link between civil engineering as well as environmental stewardship. So thank you so much for such an insightful session.
See, I have shared my website. Please circulate to all participants. If anyone want, they can communicate with me. They can contact with me. They can discuss anytime. And see, today your presentation is smart city. So before become smart city, we should be smart enough to address this problem. So from this, what you have taken the 6 days effort to make this program successful, educating on this type of environmental issue. So we have to take pledge that at least from now onwards, we have to implement these smart techniques, what we learned from this presentation. At least 1 or 2 people start educating and that will be slow and steady. It will become a big number. So with this presentation, I request all participants, please apply 7R concept from your home only. So that in that way, you are showing respect to our Mother Earth. So Mother Earth can be saved. Otherwise, we will be like what we are facing, that landfill disaster, other things. So our hard work money should be spent for a good cause, not for just cleaning the city like a transportation, collection. See, that should be done because we are creating the waste. It is our waste. We should clean. We should not depend on the government. So this is the request. Please apply 7R in your lifestyle. So let's make our country proud. So thank you, one and all. Jai Hind.
So please, everyone, please open your cameras for a group photo.
Where is Nakul?
Nakul sir is also there, sir.
I am unable to see.
Maybe there are some connectivity issues from his side. He was there. Yes, sir. Maybe Nakul sir has joined, I guess. Okay, participants. So attendance link is been given in the form. So please share it and please fill it for the attendance.
So now we are begin with our quiz. So we are sharing the details to how to access the quiz link.
Hello. Hello. Grover, I just have a question.
Yes, ma'am.
I'm checking my attendance details. However, I'm attending every day, but last two and even today's link is showing as absent. I'm not able to understand why.
Ma'am, might be there would be some technical glitch. We will look after that.
Yeah, please look into it. Yeah.
Sure, ma'am. Thank
Okay,
you for
then I
raising
will
that
move.
concern.
Thank
Yes,
you.
sir. Thank you, sir. Thank you for
Thank
joining
you.
us.
Thank you, sir.
Thank you. Thank you.
So is my screen is visible?
Yes, sir.
Yes. So
Yes, it
we
is
have
visible.
shared the Atal portal link on the chat box. So you have to just go to access to that website, and after visiting to that website, you have to just log in your details with the registered email ID, and you have to enter the password. And after that, sign in. You have seen this portal over there. You can see the assessment on the right hand side, left hand side, and there would be a link over there. You have to click the test link, and after clicking to the test link, you will directly direct it towards the quiz. And there are some guidelines for the quiz. So there are 25 questions in 40, which you have to attempt in 45 minutes, and you have to switch off your mobile phones and everything. And there will be a sample question screen also there on the left hand side, so where you can access the questions and all. And you are not allowed to copy, paste and print any content, and you cannot move your tabs and windows during the session. And this would be only valid till 6:30 to 7:30. After that, the link will get expired, and you have to fill the feedback form also on the website itself, Atal portal itself. Those who have not registered at the Atal portal, we will share the link personally to them. You have to just drop us a message on the chat in the chat box, and we will share the link to take the test. And you have to get score at least 70% of the marks for the eligibility criteria for the certificate, which will be issued by the Atal. And you all have to stay on this link on this video Zoom platform, and you can start your quiz now. And if you have any doubts, you may come to you may write in the chat box. We will resolve those as soon as possible. So we have shared the Atal portal link in the chat box.